like washing, drying, pastel-based powdering. The separate solutions of cloves and the tulsi has been prepared at easy to get temperature of 70 to 80 degrees Celsius. And then 5 ml of the clove and the other side tulsi solution has been mixed with the 45 ml of the silver nitrate solution and been incubated for 24 hours. The both sides we follow the same procedure and the same proportion, having the same physiochemical conditions. And we can see from the poster that at the primea facie, we can evidence the formation of the NPs due to the color change on the both sides. And taking different incubation temperature, it can be said that the temperature increases the rate of reaction and lessens the incubation time. We have taken different pH, and at all pH, the NPs had been formed. But at pH, pH for the higher pH, we get more durable and absorptive nanoparticles. The UV-VS spectrophotometry graph has been plotted for pH 9, and we find peak in the case of cloves at pH 9, and a little sharper peak in the case of the tulsi. But in the both cases, we cannot consider them as spherical nanoparticles because the peak seems not so sharp in the case of tulsi. And the absorption maximum for the clove is much greater than tulsi leaves. In the same condition, we can see in the graph it is 2.6 for clove solution and nearly 0.03 for the tulsi solution. In the ACM analysis, we get nanorods very clear in the case of cloves, and in the case of tulsi, it is still we are considering it nanorods of a smaller dimension. So now coming on the stability factor, and I am adding here orally. After some days, the tulsi-based NPs show shift having increase in the wavelength and decrease in the absorption maxima. While in the case of clove-based NPs, the change was not as much bigger as that in the case of the tulsi. So we can conclude that the quercetin action in the tulsi leaves is hindered by some other flavonoids present in it, and quercetin in tulsi is not as much as a strong stabilizing agent as eugenol in the cloves. And so eugenol-based synthesized silver NPs proves to be more stable and shows stronger absorption maxima than the quercetin-based synthesized NPs taken in the same ratio and in the same physiochemical conditions. That's all. Thank you.
Okay, so I have a question.
Yeah. Yes, sir.
Can I go ahead?
Yeah.
Yes, sir.
Where is the proof that these are silver nanoparticles or nanorods?
Sir, it can be tested for the antimicrobial activity or
no, but how you are saying that it is silver nanoparticle? It can be some other derived silver compound may also be formed. So you need to have the proof, like XRD or similar kind of thing. Where is that?
Yes, sir. We have taken the AgNO3 salt, so it will be the Ag ions, and we have not still considered XRD pattern and FTIR. So at present basis, we can say that it is silver nanoparticles.
In science, you can't say, just you need to prove.
Sir, we have taken initially as of the silver, so it will be a silver nanoparticles.
Okay. Thank you.
I have a question. Can I ask? Yeah.
Yes.
So, if you add this clove or this tulsi along with these organic structures that you have shown, there are also other components in them. So
yes,
how
yes,
can so there are like two questions. First is, how are you very sure that these are the compounds that are responsible for this particle formation that you are seeing? And second, what is, if I think in terms of cost, like if I directly synthesize or procure these materials from companies and then use these tulsi and cloves, which has these definitely in a much lower quantity in them, how economically viable is that?
Sir, for the first question, I want to say that according to literature review, we come to know that eugenol is the main reducing agent in the cloves, and in the tulsi. In addition with quercetin, there are many other flavonoids, but eugenol is mainly responsible for its reducing as well as capping agent. And your second question, please repeat. I am not clear about it.
What I was asking is, these these molecules in these
Yes,
tulsi or cloves, they are definitely not making the entire clove or entire tulsi. Their proportion is maybe 5% or 10% of the entire chemical composition, or even less. So,
yes, sir.
how economically viable it is to use these cloves or tulsi for the synthesis, in contrast to we just buy or synthesize these chemically from in our lab, and which one will be much more economically viable?
Sir, first of all, it will renovate the ancient floral-based values, and together with it is a green method, so it will be quite cost efficient in comparison to other methods and other materials that we use in the synthesis.
Okay. Mm-hmm.
Thank you, sir.
Thank you.
Thank you.
Any questions?
No, proceed. Nivin TS is waiting.
Yes, sir. Yes, sir. Yes, sir. Yes, sir. Can I start?
Yes, proceed.
Good afternoon, everyone. Myself, I am Nivin TS, working under the guidance of Professor Karthikeyan, Department of Physics, Jaramaishi Katangalatu, and my topic of research revolves around the effects of graphite in the polycrystallination metrics and the thermotic properties. And coming to my scope of research, we know that in thermoelectrics about like when we are considering the total energy consumption that is from the automobile, nuclear power plants, and thermal power plants, as a whole, as 100%, about 66% of the total heat that we are using is is lost in the form of heat. And so we should have some method that we could use thermoelectric as a potential method to convert this thermoelectric power to electrical energy, so that we can make the consuming energy much more faster, to more than like 33 percentage to around like 50 percentage if you are using thermoetics in a useful way. So when you are coming to my topic of research, that is in thermoelectrics, basically the challenge that we are facing now is the low conversion efficiency of the existing materials and the unavailability of the earth abundant materials that are non-toxic. And mostly when we are in the current thermatic materials, the production of 1 volt of power is costing around $25, and we have reduced at least $5 to have like commercially viable materials for most of the applications. If we have to in the material waste, I have chosen tin sulfide because it's a low cost material with high Seebeck coefficient and have unharmonic with it. So it's a layered material that has a low thermal conductivity, but the problems that are associated with tin sulfide that involves low electrical conductivity and low carrier concentration. So my objective revolves around the carrier concentration as well as electrical conductivity improvement. And my synthesis route involves a hydrothermal technique that involves specific stannous chloride as well as the thiourea as the precursors, and I had used in the hydrothermal method. And I have hot pressed my pellets around 800 degrees Celsius for 15 minutes, and then anneal to produce a pellet. Then I analyzed the structural properties of it, and I found out that from we are converting from the powder form to the pellet form, we have seen an alpha to beta phase transition in the material, which is due to because the lattice parameters that is oriented on C axis has changed to the B axis. And from the analysis, we also found out that the graphite sheets that have been produced in the SNS layers have been oriented along the B-axis. And for the further confirmation, we have found out there is a slight volume increase in the material as well as in the structural properties. And from the Raman analysis, we have found out the defects and the G-band and the G-band stage of the graphite present in the 10% compound, and we are improving the concentration above 5%. We have found out the AMG bond of SNS2 that is present in the material, so that the composite percentage that are going above 5%, we are seeing the impurity phases much more. And so from the carrier concentration point of view, we are able to improve the carrier concentration from 4.34 and 10 raised to 15 centimeter cube to around 2.05 in 10 raised to 19 per centimeter cube. But the mobility is not much higher, but it revolves around 3 to 4. And when you are improving the concentration about 10%, the mobility is coming low to around 1 and around 1, so the mobility is reducing as well. And for the further confirmation, we have done the XPS analysis, and from the XPS analysis, we have found out that the SNS is there is a energy band gap of around 8 electron volt in between the 3D 5/2 and 3/2 peaks, which confirms it's in the SN plus state as well. And we also have found there's a relation between the tin as well as the carbon, which means there is an interaction in the van der Waals bond of it. And from the time analysis of the crystalline, we have found out there is a lot of grain boundaries and stacking faults present in the material. And when we are improving because in adding the graphite to the crystalline matrix, we have found out that the crystallinity is improving inside the material, which can be a possible cause for improving the conductivity as well as improving the thermal conductivity that we are expecting it. And then we have analyzed the feedback as well as the electrical conductivity of the material. From the feedback, we have found out that they are having around 562, which is a higher feedback coefficient for the material, and when we are above going to around 5 to 10% is reducing. And the electrical conductivity shows a semiconductor behavior as well as, and we are able to improve up to around from 16.25 Siemens per meter to around 432.80 Siemens per meter for the graphite sample, and we were able to improve the power factor of the material from 6.63 microwatt per millikelvin to around to improve to around 6.63 microwatt per millikelvin for the composite sample. And I would like to acknowledge my SRM Institute for my fellowship as well as and Saif and Inasu for the characterization abilities. Thank you.
I have a comment.
Yes, sir.
You write that high Seebeck coefficient.
Yes, sir.
Did you see that Seebeck is C and Beck, and C is your capital letter is not there. Please careful.
Sir, it's not clear. Can you please once more say? I couldn't hear it properly.
So in any case, I have one question.
Yes, sir.
So what is your figure of merit? Have you calculated that?
0.2, I think.
0.2
actually.
28.
2.8.
This is 0.2. Isn't it a little bit rather smaller than the available?
Yes, sir. It is a lower value because the current values are higher, but still, when we are going for the low cost materials, we are having that problem. And I have done through the chemical precipitation method, other than the like the vacuum sealing or the higher methods that are possible. Through the chemical route, it is one of the highest values.
Yes. So your the low value is probably because of your high conductivity, right? Hello. Hello.
I think network issue.
Yeah. Hello.
So your low value of this dimensional figure of merit is probably because of the high value of conductivity, right?
Yeah, sir.
So you are saying that SNS is a layer structured material. So in that case, obviously, the conductivity can be suppressed because of this low dimensional anisotropic behavior. So have you explored that one in any way?
Anisotropy I haven't explored, but the conductivity is improved for the material when I was since it is having an insulator behavior, I have changed to a semiconducting behavior for the material. From the material point of view.
Okay, so do you have any plan for improving this figure of merit? Because if you want to commercialize, obviously you need to compete with some of the very high figure of merit materials.
Yeah,
so
currently I'm trying to improve it again actually with other like methods, like I'm changing from chemical method to the other methods.
Okay.
So that the grain boundary reduction will be there for the material, so that the conduction will be much more improved, as well as we have to see back in along with it.
Okay. Thank you.
Okay.
I have a small query. That why do you see that this when I think you're like when you change the ratio, why do you see a change in the crystallinity that you are telling? Though from the XRD it doesn't seem so, but since in the HRTM you are seeing like in some you are seeing the grain boundaries and in some you are not. You are kind of concluding that the crystallinity is changing. So why do you think that the composition has an effect on that?
Sir, actually, when the graphite composite is improved in the material, when when we are putting the graphite composite to the materials, mostly like in the reports as well, there is a lot of crystalline improvement has been reported. I'm not in the graphite from the XRD analysis. I am not seeing a bigger change, but there is a change in a slight change towards the higher angles when we are adding the composite percentage. That is what
My question is, why is that so? Like,
my comment was that you wrote that high Seebeck coefficient. It is Seebeck coefficient and C also small. That I wanted to tell you. Please be careful.
Okay, sir.
Okay, any question?
Next.
Okay. Pawan Kumar Pandey is around?
Yes, sir, I am present.
Okay, so are you ready?
Yes, sir, I am.
Okay, go ahead.
So, sir, can I start?
Yeah.
Yes, sir. So, hello, everyone. Myself, Pawan Kumar Pandey, and the topic of my presentation is green synthesized silver nanoparticle and ECM aloe vera based nanostructured scaffold for infectious wound healing. Coming to the introduction, as we know that chronic infectious wounds are difficult to treat because a number of pathogens multiply in the wound area and cause and promote the inflammation. That's why they retard the healing process and worsen the conditions. Chronic wounds, they also generate free radicals.
Hello?
They further causes the cell damage.
Turn on your camera.
Oh, just a minute, sir. Is it okay, sir?
Yeah.
Okay.
Yes, sir. So ECM based biomaterials since they have natural compositions, so they are supposed to be the ideal for wound healing by tissue engineering. Goat ECM or extracellular matrix, they are reported to be less immunogenic compared to the porcine or bovine ECM. That's why goat ECM can be a better candidate for tissue engineering applications. And it is also reported that green synthesized or neem-based silver nanoparticles, they have strong antibacterial as well as antioxidant property. So aloe vera gel is also reported antioxidant and wound healing properties. So was our hypothesis to prepare a scaffold based on the ECM, silver nanoparticles and aloe vera gel. So main objective of my research was fabrication of nanocomposite matrix scaffold for infectious wound healing. So in the sub-objectives were preparing DGCS gel, synthesis of green synthesized silver nanoparticles, preparing of DGCS aloe vera gel, and preparing of the composites, then evaluation of the system for infectious wound healing applications. Coming to the materials and methods, first of all, we collected the neem leaves and prepare aqueous extract, and then we prepare the silver nanoparticles using the silver nitrate. Then we prepared the aloe vera gel from aloe vera leaves and the DGCS hydrogel from DGCS powder. From the gel and aloe vera gel, we prepare DGCS aloe vera gel, and combining the silver nanoparticle in different ratio, we have prepared different amounts of different samples using sample A, B, C, and D, in which the silver nanoparticle was present in the 0 microgram, 5 microgram, 10 microgram, and 15 microgram per ml concentration. So the phytochemical analysis of the aqueous extract of neem leaves was present that saponins, steroids, and terpenes were abundantly present, and tannins and glycosides were moderately present, and alkaloids were least present. Coming to the analysis of the nanoparticles, we can conclude that via DLSA analysis, the hydrodynamic size were 104 nanometer approx, PDI was 0.29, and the zeta potential was -17. The UV spectroscopy showed the formation of silver nanoparticle by showing the peak at approx 450 nanometer, and FSM graph shows that the particle size were approx 50 to 100 nanometer size. AFM graph showed that they have lattice fringes of 3 to 10 nanometers. Coming to the scaffold characterizations, we came to conclude that the Pore size of the samples were ranges from 143 to 185 micrometer. Porosity was 72 to 90%, and swelling was 1575 to 1900%. The scaffold characterization via FSM, we conclude that the honeycomb structures where interconnected morphology was obtained, which was ideal for the cell culture. Coming to the TGA curve, we conclude that there was no significant weight loss up to 200 degrees Celsius. And FTIR curve showed that the presence of neem, aloe vera, and ECM contents in each and every samples. XRD curves shows that there was no sharp peaks was there, confirming that there was all samples was amorphous in nature. So antibacterial activity showed that the scaffold D, which was prepared, they show the highest antibacterial activity against both E. coli as well as S. aureus, and all the scaffold were antibacterial nature, but scaffold D was highest. Coming to the cell attachment assay, they are showing that all the samples were showing more or less similar type of significant cell attachment in all scaffolds. Via DPPH scavenging activity, we concluded that all the scaffolds were having antioxidant properties, and when we check the cell proliferation assay by L929 cell lines, they were showing all samples were biocompatible, but minute cell toxicity was seen in sample D. So we conclude that sample A, which was having the maximum cell proliferation, but least antibacterial activity, while sample D, which was having highest silver nanoparticle concentration, they are having highest cell toxicity also among them, but not suitable for the cell culture. So the developed nanocomposite scaffold could be a better potential material for the chronic infectious wound healing applications. This was my presentation.
Okay. Question?
So, Pawan, I mean, like the previous speaker, the questions that were asked by the judges as well, what is the role of these particular like aloe vera or neem that you're using on making, because the silver, I mean, at the end of the day, you are using the nanoparticles, which is the extract. Final thing is what you are getting.
Yes, sir.
So what is the purpose of using these, what you call as green, substances?
Yes, sir. So coming to the neem leaf extract, previously we were talking about, since neem contains a number of biochemicals, phenols and terpenols, saponins, they contains the antibiotics or microbicidal nature. They have a synergistic antimicrobial effect. And our aloe vera leaf, which contains aloe vera gel, they promote the wound healing by altering the collagen composition, which is present as the wound site, by altering the collagen synthesis. And collagen is very much required in the wound healing. And that's why aloe vera promote the wound healing. And the DGCs, which we prepare for the infectious wound healing, they provide a scaffold for cell culture. As we can see that the scaffold characterizations, they have the porous structure, 3D structure. Okay. They are interconnected and cells can grow very easily. So proliferation, growth, and differentiation of cell is highest in these compositions. So they cause synergistic effect in wound healing.
Okay. Thank you.
Yes, sir.
I have a question, Pawan.
Yes,
you
sir.
have shown that your average particle size is around 100 nanometer, right?
50 to 100 nanometers, sir.
So you have a wide size distribution, right?
Yes, sir.
So
it was my observation, but the PDI was showing 0.29 only.
0.29 only PDI.
Yes, sir. Because when we observed and we scaled, the particle size were 50, 60, or maximum 70. Very few particles were up to 100 nanometer.
So here you have seen the particle size. Obviously, this represents the average one. So
yes,
I'm
sir.
assuming that when you are putting 100, 104, that is the average one. But you are saying that 104 is the upper limit.
Sir, actually 104 is hydrodynamic size, not the real size. Hydrodynamic size is always 30 to 40. Yes, sir.
Yeah, I understand. Yeah. So have you did some image analysis to check what is the size distribution? Because for this kind of synthesis process, uniform size distribution is very important.
Yes,
And
sir.
if
Yes,
you have a
sir.
control on that, that will be a very good synthesis process. Otherwise, this green synthesis, although they are saying green synthesis, is not the green synthesis. Actually, this is the green synthesis or surface functionalization for this antibacterial property. Otherwise,
Yes.
it is basically the same inorganic process where silver nanoparticles is formed from AgNO3.
Yes, sir. Yes, sir.
So this is kind of a misnomer what everybody is using. So
Yeah, although that was my question as well. I mean, whether
exactly
it is, yeah,
that's what I'm saying. Yeah.
thanks for clarifying. Yeah, I was just like
Yeah.
wanted to understand this as well. So okay.
Yes. So in any case, so you need to check how you can control the size distribution. So,
Okay, sir.
so that
I
will
will.
be your future work. Okay. So
Okay,
that's
sir. I
the
will.
comment. Okay.
Okay, sir. I will do it, sir.
Okay. Thank you.
Thank you, sir.
Okay, I have one question.
Yes, ma'am.
Am I audible?
Yes, ma'am. Yes, ma'am.
Do you have any proof of collagen regeneration via aloe vera extract?
Ma'am, it is reported
Because-
in the several research
Yeah,
papers.
I have found many papers and also commercially available patches where
Yes, sir.
these compositions are being used, like silver nanoparticles along with aloe vera gels and other
Yes, ma'am.
things you have mentioned. So, what is your USP? What is the USP of your composition?
Yes, you are asking about, ma'am, novelty of this research?
Yes, exactly.
Yes, ma'am. Ma'am, novelty here is the DGSS powder. This is patented in our lab. This is prepared in our lab, and it is the novel thing. Because, hello?
Yes,
Go
yes,
ahead,
carry
go ahead.
on. Go
Yes,
ahead,
sir.
I'm listening.
DGSS powder is DGSS or decellularized goat small intestine submucosa, ECM. This is novel in this research paper because it is not used before. It is developed in our lab, and we are checking the biocompatibility and cell
Oh,
proliferation.
actually, you are using a specific extracellular matrix.
Yes, ma'am.
So the novelty lies in the ECM, not in the composition.
No, ma'am.
Okay, I got it. Thank you.
Thank you, ma'am.
Any question?
Yeah, I have another question. Have you cross-checked the toxicity of the ACM?
Toxicity of the means where
Whether it is having any adverse effect. Pardon my throat. Actually, I'm having fever right now. So any adverse effect it is being given like for wound healing for the
Ma'am,
ECM matrix.
ma'am, since our senior have developed it and he has checked that this goat ECM is non-immunogenic and promoting the cellular differentiation, it is non-toxic to the normal cells as well.
So you have all the data of immunogenicity.
Yes,
Yeah.
ma'am.
Thank you very much.
I hope there is no more question. Sagar, do you have? Okay, so shall I move?
No. Mhm.
Yeah. So I'm going to the next. So,
Thank you very much, sir, for this opportunity.
Yeah.
Thank you.
Now it is turn to Sion. Sion is around. Sion Poida. Sion Poida. Okay.
Yes, sir.
So you're around?
Yes, sir. Yes,
Okay. So are you in position to start?
yes, sir.
Okay. So shall you turn on your camera?
Yes.
Yeah. Go ahead. Start.
Okay. So I am San Poida, the research scholar of Department of Physics, Rothman College, Contact. Here I am presenting the thinking photodetectors based on chemical bath deposition towards ambient stability. First of all, what is photodetector? Mainly photodetectors are sensors that can convert the photon energy of light into an electrical signal. So here for facile fabrication, we used chemical bath deposition because chemical bath deposition is a facile fabrication process, and For photo detectors are used many modern imaging and communication system, and also in scientific research, national defense, in many industrial production. So here we ultraviolet photo detectors and infrared photo detectors. For ultraviolet photo detectors, we have choose the ZNS zinc sulfide layer, and for infrared photo detectors, we have choose PVS, that lead sulfide layer. And here is the fabricated thin films in our lab, the ZNS and PBS. And for this fabrication, ZNS and PBS, we have to first confirm that the temperature of this is 60 degrees centigrade, and the pH level also of the solution should be maintained properly throughout the process, because if the pH level is not maintained, then the thin film should not be grow properly, and there should be some cracks, and this is not uniform. Okay, and at the top we have used 18 nanometer of copper by sputtering, DC magnetic sputtering at room temperature as a top electrode. Then anode, and the cathode is FTO. We have used FTO. And here is the chemical bath deposition fixture that we used, chemical bath deposition fixture. And from UV absorption spectrum, we have seen that the absorption of ZNS is near about 400 and less than 400. That means at ultraviolet region. And because the ZNS, we have choose ZNS because ZNS have lower, highest band gap. So that's why HC by lambda, that is lambda is small for ZNS, the absorption spectrum. And we optimized for this layer purification at 6 hours, 8 hours, 10 hours, and 12 hours purification. So for 12 hours purification, the absorption is maximum. And also for PBS, we have characterized the absorption. It's near about infrared region, because the PBS layer has less wavelength region, and our device architecture is on the top of the glass there is FTO, and then PBS as a electron, FTO as electron etc., and electrode copper is used as a hole, etc. And we successfully devised these thin film photo detectors based on chemical bath deposition towards ambient stability, and this synthesis process is also low cost purification. So, and the dark current of this device is near about nanoampere order, microampere order, and when light is situated on this device, then the current is near about milliampere order. And that's it.
We have done.
Yes.
Any question?
I have a question. So, from your device architecture, what is the thickness of your PBS and ZNS layer? Thickness?
Yes, PBS and ZNS is near about 40 nanometer, and the
40?
copper is nanometer.
Nanometer.
Yes.
And your electrode is, I see the 80 nanometer. So your electrode thickness is higher than the active layer thickness.
It's 40 nanometers. Yes, and not PBS and ZNS. Actually, both means are near about 100 nanometer both.
Both 100 nanometer.
Yes.
Okay, and you are saying that ZNS is deposited by CVD with varying deposition time. So that means you are changing the thickness of ZNS also, right?
Yes.
So what is the range?
And the 12 hour, when I device fabricated for 12 hour, and there's the maximum value of absorption coefficient.
No, I'm talking about you are saying that in your device fabrication, you're saying that generous thin film layer is deposited by CBD at room temperature of a varying deposition time. So what is the reason you are varying deposition time? I believe it is because of your changing thickness, right?
Changing thickness, yes, sir.
Yes. So what is that range? So what is your range of deposition time that is changing the thickness? What is the range of your thickness?
Thickness is less than 100.
Minimum, what is the maximum you have taken?
Yeah, there's 100 nanometer, less than 100 nanometer.
That is one. So what is the minimum deposition time and what is the maximum deposition time for this generous deposition?
Minimum is near about 6 hours, and maximum is.
So what is the thickness for that 6 hours?
6 hours means 40 nanometers near about.
Have you checked it, or you just some speculating data?
No, sir. I am checking from literature.
From literature, well, okay.
Because there is no instrument. I have checked it by when 12 hour is I have done. I have checked.
No, there are instruments, but maybe it is not available. So in any case, so there are many instruments there available for thickness checking. So in any case, so that's one thing. And what is your excitation wavelength for PL?
For PL, the excitation wavelength is 370. No.
Okay, thank you.
And you told your dark current to light current is microampere to milliamp. Where is the data? And are you sure that it is increased from microampere to milliampere?
No, sir. Microampere range to milliampere range.
What you want to do?
In solar stimulation, from solar actually.
Where is the data?
Due to space, I have
solar stimulation or solar simulator? What
solar stimulator.
Stimulator or simulator?
Stimulator.
No, it is a simulator. Anyway, any more question?
No, I was actually having the same question about this current change that you already asked. Mm-hmm.
Any other question? So, I think there is no more questions. So
I have one question.
Yeah.
I just want to know, like, from this PL spectra, like, can it be this much narrow? Because I don't have any idea about this zinc sulfide. I just want to know, because normally there will be some broadening.
Yeah.
Here it's very narrow.
Yeah, it's correct. Yeah, just too much narrow. Yeah.
Like I never saw this kind of narrow.
And you normalize this PL intensity. Did you? What is that? Your original? What is the intensity count or?
What's normalized?
You normalize it, yeah?
Yeah.
Did you perform yourself or somebody did on behalf of you?
No, sir.
Okay.
Or have you like changed the excitation wavelength and have you checked the emission peak, and every case you are getting this kind of narrow peak?
Yes, sir. Yes, ma'am.
Okay.
Some issue is there. Anyway, so yeah. Shall I move?
Yes.
Yes.
Okay. Thank you, Sayan. Thank you.
Thank you.
Our next presenter is Sunil Luhar. Sunil, are you around?
Am I audible, sir?
Yes.
Okay. So, good afternoon, all of you. Myself, Sunil Luhar, a CSIR RMIT research scholar at CSIR CSM CRI Bhavnagar. Today, I am going to present my work on silver deposit plastic chip electrode as an electrochemical biosensor for early diagnosis of type 2 diabetes Gospin biomarker. So idea comes from the patient and doctor's conversation. So patients are thinking like, I have put a lot of weight gain, so should I have diabetes? So doctor also thinking he is coming from my side and he is so straight, so maybe he has a diabetes. So he both are discussing about that two things. So Doctor told, yes, there is a possibility of the diabetes. Why don't you go to prognosis through biomarkers? So patient don't know about that biomarker. So he told like, what is that biomarker? So biomarker is nothing but it is an indicator confirming the presence of disease well before it appeared of the symptoms. So how can I do prior prognosis? So nowadays, like in India as well as in world, we need like point of care testing device. For the first point of care testing device is like a glucometer for that diabetes detection. So here for the detection of VOSPIN is a type 2 diabetes biomarker. So detection of VOSPIN has been done by chemical as well as optical method. Although these methods like a multi-step procedure and require like a large time, like a time consuming. So developing low cost sensitivity, sensitive fast response electrochemical sensor are challenging. In this research, electrochemical sensor was used to synthesize spherical silver nanoparticles of affordable PCE, and the antibody was attached on through self-assembly monolayer. So sensing was performed using electrochemical impedance spectroscopy. So thing is like mostly people are using like glassy carbon electrode and skin printed electrodes. So here we use plastic chip electrode that has been patented and that fabricated by our group using like polymer and graphite to polymer as a like polymer as a binder and graphite as a filler, and then it used as a support of that electrochemical sensor. So here PC is I have deposited silver nanoparticles on that PC, and that silver nanoparticles after the deposition of the silver nanoparticles, 4 ATP has been attached through self-assembled monolayer, and then antibody have a specific receptor that antigen has a specific antibody that is VOSPIN for the type 2 diabetes, that is a VOSPIN. That silver nanoparticle has been confirmed by the transmission electron microscope. So in this transmission electron microscope, you can see like silver nanoparticles distribution that is like 20 to 15 around 20 to 15 nanometers, and that also has been confirmed by the plane has also been confirmed by the SAED as well as XRD. Then attachment of the antibody has been confirmed. Antibody and antigens has been confirmed by the EDX spectra. So in this EDX spectra, you can see the plastic chip electrode deposited silver nanoparticles. So spherical silver nanoparticles in this color, red color shows that silver particles, and that other has like a carbon and oxygens. So in case of bare PC, electrochemically deposited silver nanoparticle PC has only 3 components, that is silver, carbon and oxygens. But after the attachment of that antibody antigens on that electrode surface, you can see different colors of the different layers on that spherical nanoparticles, and that nitrogen has been confirmed by the EDX EDX mapping. So here in that EDX mapping, we are getting like 14.53 atomic mass weight percentage of that nitrogens. And other thing is that has been confirmed by the electrochemical impedance spectroscopy. So in this electrochemical impedance spectroscopy, thing is like that PCE has a like charge transfer resistance is like 250. When we have deposited silver nanoparticles on that electrode surface, conductivity will be increased. The charge transfer resistance will be decreased, because resistance is like reciprocal of the conductivity. So when resistance is decreasing, then conductivity is going to increase. So in case of ATP glutathione on the PC, some semi-liquid layers, like biological liquid layers on that PC, so charge transfer should be increased. So in that control and experiment, you can see that plastic chip electrode has like 250 resistance to near to 100 to 150 resistance, charge transfer resistance. But when we have deposited silver nanoparticles on that electrode surface, it decreases. After that, we are immobilizing ATP and then probe, so it is going to increase. Then we have tested in. Yeah, hello. Am I audible?
Your time is over.
Okay, thank you. So for the in this conclusion that that confirmation has been done, it start 3 o'clock. Okay, it's okay. So its conclusion, in that conclusion, we have tested our electrochemical sensor using impedance spectroscopy, and that silver nanoparticle has been confirmed by the SEM as well as TM. I would like to thank my SCSIR supervisor and RMIT Australian supervisor. He has helped me at every step of the research and science dedicated to provide me platform to present my thesis work. Thank you. Is there any
Okay.
questions?
Yeah, I
Yes.
have.
Yeah.
Can I go ahead?
Yeah,
Yes.
one by one. Yeah.
So my question is that for your electrochemical sensing mechanism, your main parameter, variable parameter is RCT,
Yeah.
which is changing, and because of that, through that you are saying that it has better or not. But there are, if you from your equivalent circuit, there are RS or the Warburg impedance.
Yeah.
That are also there. So so that means when you are changing RCT, you are assuming that other parameters are constant. So how can you ensure that your ohmic resistance, RS or series resistance or Warburg impedance, they are same?
Okay, so here you can see that charge transfer solution resistance RS is 0 to 14s. You can see that so here that all peaks is coming from near to 14s. So RS solution resistance has is near to like 35 to 40s. Then that Warburg coefficient should be like in at 45 degree, but it is not in on 45 degrees. So its value is near to similar. That's why we have chosen this signal, this circuits. And Q is always for the, in case of capacitance, when we are talking about one electron transfer mechanism, here we use ferroferry. In this ferroferry mechanics, we are use like one electron transfer. So Q equals to 1 as case of like capacitance. So here at the every stage, we are getting double layer. That's why we have chosen like Q, or Q is always like a 1. If you will take C here, then it will be changed.
Okay, understand. And for your fabrication step, you have started with commercially available silver nanoparticle, right?
No. It's deposit. It's synthesis by electrochemical methods, like deposition of the simple electrochemical deposition.
What is your source material? Silver source.
Silver nitrate. So actually, silver
started
is
with silver
deposited on that nitrous solution will be there only in that electrolyte.
Okay.
Yeah.
Understand. Okay, thank you.
Other thing is that my thesis also one of the paper has been published in that biosensor bioelectronics, and then gold has been used here. This is in that reference.
Yeah, Sagar, you have question.
Yeah.
Yeah, I have just 2 quick questions.
Yeah.
The
sure.
first is in the impedance data, your
Yeah.
solution resistance is almost 40 ohm.
Yeah,
right?
near to 40. Yeah.
So isn't it too high for reliable electrochemical data? If your solution
No,
resistance,
it's if it will be like if it will be like 100, then also will not affect, because our main things is to measure charge transfer resistance. Charge transfer resistance will be measured to, like, if solution resistance is in 100, then charge transfer resistance will be measured to 100 to where it is going. So it will not affect that, because in every, like, when we will go with doctors, they check calibration curves. So here we have a calibration for blood plasma as well as like aqueous samples. So we will test using the charge transfer resistance, not a solution resistance. So that will not affect maybe.
Okay, I have
because
a question.
to my
Oh, sorry.
Yeah.
Sorry.
Yeah.
Go ahead.
yeah, and the second thing is for the commercial glucometers that we have now,
Yeah.
the error range is approximately 20%.
Yeah,
So-
here we have a 15%, 10 to 15%. Here that we have measured in even we have reproduced data 3 times to 4 times. So
Okay, so it's better than the commercialized ones.
yeah, but that one is that for type 1 diabetes. It is for type 2 diabetes. So type 1 diabetes, we have a glucometer that also work on principle as impedometric sensors. not for others like opticals. And first electrochemical instruments we have like glucometers.
Okay.
Yeah.
Thanks.
So, Sunil, what is Waspin actually?
Okay, Waspin is like a proteins, serpine A12. There is like
how it is. Connected to type 2 diabetes. How it is?
It is related. It is most of paper. It is in literature. So I
how
go
it
through
is related? Do you know?
I exactly I don't know, but that is in literature. That is found in literature. It is selective for the type 2 diabetes. That's why we have purchased from Sigma Aldrich. We didn't synthesize this one in our lab.
So higher the diabetes, higher is the diabetic markers, higher will be this Waspin.
Yeah, because in the things also there is two things. One is that glucose, and other is that HbA1c, other is biomarkers.
Yes.
So
yes,
both things will be like increased, then it will be work. Waspin will be work. That is in nature also.
Okay.
Yeah. Is there any questions?
Hi, actually, I was asking about the precision of detection of your techniques.
Okay, precisions for what? Like actually, we are using like cells, so maybe we have measured the error bars. So maybe precisions for what? What
Do
kind
you have
of?
any statistical data? How much quantity it will detect?
Yeah,
by
this is a picomolar. That is in that 10 to power minus 15.
So
That
you have data that you have detected in real time, like in blood?
Yeah. In that second, in that impedometric sensor, we use blood plasma.
Okay, blood
It is
plasma. Have you
yeah.
treated the plasma previously, or you have directly
No.
plasma
We took blood, and then using that blood we extract plasma. Then
that I know. So
yeah.
you don't treat the plasma anyway. You just give the plasma. So there
Yeah.
is no
We use
pre-treatment
plasma and then
required.
we spike the things.
Sorry.
We use plasma. We actually purchased we went to like blood bank and then take blood, and then after that we extract plasma. Then we spike
Okay.
different. Yeah.
Okay.
Yeah.
Thank you very much.
Yeah. Welcome.
Yeah. Okay. So shall I move? Yeah, I think I need to move.
Thank you so much, sir.
Yeah. Thank you, Sunil. Yeah. So our next presenter is Dr. Narayan Chandra Misra. Dr. Misra. Dr. Narayan Chandra Misra. I think she is in. Swati Sharma. I think she will be presenting. She informed me. Swati Sharma is around?
Yes, sir.
So okay. So shall you turn on your webcam and just go ahead. You start your presentation.
Hello.
Sorry, I am interrupted. After completion the presentation, 2-3 question will be allowed. Okay, otherwise there is too much late.
Yeah, anyway,
okay.
I talked with Sion. Maybe we can start our next session, means that will be starting at 4 o'clock, maybe around that. I informed the speakers also. I informed the past speaker. Okay. Yeah. Okay. Start, Swati.
Hello. Good afternoon, everyone. I'm Swati Sharma, PhD research scholar from IIT Roorkee. So the topic for my presentation is design and synthesis of carbon dot peptides, conjugates, and their theranostic application. As we are well aware that whenever we talk about some disease conditions, so more or less these disease conditions are related to protein. So like either protein is deformed in that condition or some structural variations have been done in that protein. So if in that way, if the procedure or the like the methodology behind the disease is working on. So if we can have a single platform in which we can diagnose different proteins which are related to various deadly diseases. So it will become quite easier to detect all of the diseases related to various proteins under a single platform. So that is basically the motivation behind my work. So in that, what we have basically tried, tried to synthesize the carbon dot using the waste biomass material and use them for the detection of multiple proteins. So if we talk about why we have used the biomass, so the motivation behind using biomass is that if we are using biomass, so like in that way the waste management can be done very smartly, and secondly the thing is cost effectiveness can be seen. So if we are buying very expensive chemicals and then we are making some product, then the industrial scale conversion of that product becomes quite a challenging concept. But if we are using any waste, so the waste can be fruitfully utilized and the useful product can be made out of that. So similarly, we have tried synthesizing the carbon dot using leaves only from green plants, and after synthesizing those carbon dots, we have tried to use heterodoping with the carbon dots. So actually the surface of carbon dot is quite active. So if we will functionalize it with different groups like nitrogen, sulfur, and like manganese, these kind of dopings can be easily done on the surface of carbon dot. So because of which the fluorescence intensity and quantum yield of those carbon dots can be enhanced. And after preparation of these heterodoped carbon dots, we have tried to conjugate those carbon dots with different kinds of peptides. And we have considered choosing the peptides considering that for which particular diseases they are specific. And secondly, we have also tried checking that with amino acids also. 4 sets of amino acids we have taken: positively charged, negatively charged, neutral and aromatic amino acid, and then we have tried making the assemblage with those carbon dot and amino acid assemblage, and then we have tried to check it with different proteins, that how they are interacting with different proteins, and using statistical analysis these can be done. Other than that, if we talk about carbon dot applications, so they have good role in treatment of cancer, that is photodynamic therapy. So photodynamic therapy is a good alternative for chemotherapy. In chemotherapy, what actually happens is along with the healthy cells, the cancer cells also along with the cancer cells, the healthy cells of the body are also affected. So ultimately, it is not a fruitful solution. But if we talk about these photodynamic therapy, in photodynamic therapy, what happens is only the cancer cells are targeted and they will be killed using the concept of that singlet oxygen generation in our body. Okay, and apart from that, we have after synthesizing this carbon dot, we have seen that to just confirm that whether carbon dots were synthesized or not, the optical characterizations were done, UV spectroscopy was done and fluorescence spectroscopy was done. So in case of UV spectroscopy, 2 peaks were obtained. One peak was near about at 265 nanometers, second was at 320 nanometers. So these peaks basically are because of pi to pi star transition and N to pi star transition. After confirming the formation of carbon dots by UV spectroscopy, we proceeded with the fluorescence spectroscopy. And in case of fluorescence spectroscopy, we have seen that the carbon dot was showing excitation-dependent emission to luminance. That means, whenever we are changing the wavelength with the difference of 10 nanometers, so the emission of the carbon dot was also shifting. So in that way, also this can be a good property of carbon dot, which can be used where we can modify the emission of the carbon dots. And another thing is the surface, the carbon dots basically are amorphous in nature. So to check this thing, we have employed the powder XRD of the carbon dots. Later on, TCS/PC of the carbon dots were done just to check the lifetime of the carbon dots, and these carbon dots have such a short lifetime, that is 9 nanoseconds. And apart from that, if we talk about the surface morphology of the carbon notes, we have gone with the HRTM characterization, and in that we have found that the carbon notes were quite spherical and like 3 to 4 nanometer in size. So such a small size carbon notes are very easy to be taken up in the cells by the process of endocytosis. So in that way also that is like a thing. And if we talk about the charge which is basically present on our carbon notes, so our synthesized carbon notes basically were like negatively charged in nature. So when like if we go to know that like if the zeta potential is coming negative, so we can say that our synthesized carbon notes are quite stable also because they are well dispersed.
Your time is over. Sorry to interrupt you. Your time is over. Already 6:22. Yeah. So any question from judges?
I have one question.
Yeah.
I just want to know like how you are being ensured like these carbon dots are being doped by this manganese, iron, and nitrogen. Like have you compared like before doping and after doping how their absorbance or PL spectra is changing, or how they are interacting with these peptides in absence of this doped element?
Yes, ma'am. That we have checked. We have actually tried to synthesize carbon notes in very different sets. Okay. Initially, we just synthesized the like using that plant extract. Normal carbon note we have synthesized. Then we have tried to like dope fluorine and nitrogen, and in like 4 to 5 different sets we have synthesized, and then we have compared the results. And like then the work was proceeded with that best possible set which we have obtained.
But have you compared like without any doping and after doping?
Yeah, ma'am. We have compared. There was the difference in quantum yield which was obtained in the case of carbon. Yeah, like after doping.
Then after doping, is there any change in their absorbance?
Ma'am, in absorbance, there is no major change after doping, but the quantum yields basically have been enhanced by like 1 to 2% after doping.
Okay, because I think like if there is any element is getting doped, then there can be some change in their energy levels. So maybe there can be something change in their absorbance spectra also.
No, ma'am. Actually, basically, what happens is like it depends on plant to plant source also. Like in many cases, if you will see that in case of some plant, only one peak is obtained, like at 270 or 280 nanometer, only one peak is obtained, which is because of pi to pi star transition. But in case of some other plant material, you can obtain those 2 peaks also. So it also depends on the phytochemical constitution of that plant source also. Like we don't know what are the secondary metabolites and different compositions which are present in that plant. So that factor is also considerable in that case.
Okay, but at least have you confirmed like the presence of these elements like by some like EDAX kind of things as
no,
we are
ma'am,
doing
that
like...
characterization we have known.
Okay.
Yeah, ma'am. Actually, this is like my second semester only in PhD. So currently, like with coursework only, like we have just started this work.
Okay.
Any question? Any other question? Sagar?
No.
Okay, so I think there is no more question. So I'm
okay.
So next presentation is by Riyanka. Riyanka is around?
Yes,
Yeah.
sir, I'm here.
Yeah. You present.
Okay, sir. Okay, sir. Good afternoon to all of you present here. I'm Riyanka Das from CSI, CMERI, Durgapur, and ACSI. So all of you know that the development of single and expedient sensor receptor is the arch of current scenario in terms of environmental protection, food spoilage evaluation, that is food quality monitoring, as well as for medical diagnosis. So amines are ammonia, and different kinds of aliphatic amines. These are widely used in different kinds of industrial sectors. So apart from its useful industrial applications, these are low molecular weight volatile amine like ammonia, triethylamine, hydrazine. These are basically toxic for human health and sometimes can act as biomarker for different diseases like your prostate cancer, uremia, etc. So in this perspective, in the present work, we have developed a phenazine kinds of molecule, namely CN2, which is synthesized from a simple aromatic amine octanoacetyl in presence of FeCl3 as catalyst and oxygen as oxidant. And you can see the crystal structure here from where structural authentication has been done. And you can see from the structure very minutely that it has a monoprotonated imine site. So it actually inspired us to think that if it has the capability towards detection of some kinds of alkaline amine odorants. So from the study we have seen that from the UV spectral study, starting from ammonia and different kinds of amines like aliphatic amines, 1 degree to 2 degree to 3 degree, there was sharp chromogenic change was observed. Along with these, sharp UV spectral change was observed, and this is basically due to the deprotonation of the monoprotonated imine site. And from the fluorescence spectroscopic studies, also you can see that there is Turner fluorescence response, and this is basically due to photo-induced electron transfer after deprotonation. Now, inspired by all these things, the sensing capability of the developed material towards sensing of aliphatic biogenic amines like putrescine, sparmidine has been investigated. As you all know that these amines are highly important as this can act as potential biomarker sensor for prostate cancer, as also it can act as potential food spoilage or fish spoilage tagant. So from this UV phase and fluorescence spectroscopic studies, you can easily understand that it has the capability towards detection of these kinds of amine also. And from the 1H NMR and DFT studies, you can see that the NMR proton signal for the monoprotonated imine side, that is NH proton signal at around 9 ppm gradually reduced, which is basically supporting the deprotonation factor, and other aromatic proton signals are also upfield shifted, which are also indicating the increasing electron density after deprotonation. And from the DFT studies, you can easily understand that the delta E value is increased upon introduction of ammonia or amines to CN2, and this is basically corroborating the blue shifting of the UV spectral data. And based on this mechanism, the plausible sensing mechanism has been demonstrated here. Now I will show some reality analytical application. You all know that for our scientific community, any developed chemosensors will be highly desirable if it has some reality application. So first thing is solid state sensitivity of the material. To check the activity, solid state sensitivity of the material, we have developed CN2 based test strip. And when these are exposed to ammonia or immersed into the amine solution, there was obvious chromogenic change from blue to purple. And based on this, you can easily understand in your sample amine is present or not. Next one is lab on a mobile device. Nowadays, we all have a smartphone. So smartphone assisted technique is always advantageous over other conventional technique. And for this, we have taken or adopted an RGB app color graph, and from the figure you can easily understand that with increasing the concentration of ammonia, the color is changing gradually from blue to purple, and accordingly from the images were captured from the smartphone camera, and the RGB values were extracted from them, and the R by B value was plotted against the concentration of ammonia, and you can easily understand the concentration of your ammonia or other amines. And for the authenticity, we have checked the unknown concentration both by the spectroscopic method as well as the smartphone assisted technique. And next one is the important thing, that is prostate cancer biomarker sensor. You all know that in case of prostate cancer, the patient who is suffering from this disease, the concentration of spermidine putrescine is highly increased in their urine. So by non-invasive technique, you can easily understand patient is suffering from this disease or not. So for this, I have taken urine sample and externally spiked with spermidine and putrescine. And
Priyanka, your time is up.
Okay, sir, 2 minutes.
Continue. Yeah.
Okay, sir. So from the data, you can see that material has the capability towards recognition of prostate cancer, as well as fish spoiler sensing capability, and ultimately CMERI has indigenously developed a portable prototype based on CM2 functionalized hydrogel membrane, and based on this, real-time detection is also possible. That's also.
Okay. Question?
Yeah, I have a small query. So, do you have like interference data? Because it's definitely okay.
Yes, sir. I have carried out the selectivity as well as the cross-interference studies, taking with different kinds of volatile organic compounds like methanol, ethanol, DCM, as well as different kinds of aromatic amines, which are actually interfering those kinds of detection. But there was no interference from those kinds of volatile organic compounds as well as any kinds of aromatic amine.
Okay. Yeah. Thank you.
Thank you so much, sir.
Any question?
Yeah, I have one question. Yeah, the amine has been detection biomarker for liver and kidney screening also. There are various
Sorry, ma'am?
diseases.
Oh, amines has been detected for prostate cancer biomarker sensor.
Yes, but other diseases for also like liver and kidney screening testing. So how you are going to, if say you are having some patients, you are detecting the amine or whatever you are saying, that aliphatic amine sensitivity. So how can you differentiate that whether he or she is having liver or kidney screening, kidney
Actually,
diseases
ma'am,
or prostate cancer diseases?
sure,
Is
ma'am.
it a correlation study?
Actually, my target is to detect the spermidine filtration kinds of biogenic amine, and you know that the biogenic amines are generally exerted or excreted for
Yes, I
urine
can
at a
understand
certain
that. I
percentage.
can understand that. But how? My question is, how can you differentiate among the diseases with this biomarker?
How can I correlate it? Actually, ma'am, the concentration level of biogenic amine is increased during these diseases from 10 to 50 micromolar. So, from the concentration range, I can easily understand the patient is suffering from which disease.
Is there any data for this concentration range? I don't think so, because every diseases has it has a great variability as per my concern. So please check it out. This is a big concern now in electronic nose research. So if you can check it out, it will be helpful for you.
Okay, ma'am, I will definitely check, but it's a multi-dimensional research work. That's why I have worked in different domains, like your fish spoiler sensing or anti-counterfeiting activity, as well as prostate cancer. So a single molecule, how it can multi-dimensionally work, I have checked that thing. So in future, I will definitely work on this.
Thank you very much.
Thank you, ma'am.
Any other question? I hope no more question. So thank you, Riyanka. So shall I move to next one?
Thank you so much, sir.
Now the next presentation is by Tapos Das. Tapos is around. Mr. Tapos. Oh, this presentation is done or no? I think Tapos is not here. Tapos is there? Tapos Das. Okay. I am audible?
Yes.
Okay.
Yes, sir.
Okay. Who is telling yes, sir? Tapos Das or what? Okay.
No, Tapos is not present.
So next presentation is Sangeeta. Sangeeta is around? No. Sangeeta is around? Sangeeta VC?
Yes, sir. Yes, sir. I'm here.
Okay.
Hello.
Yeah. Yeah,
Yes, good
carry on.
good-
Yeah, are you in position to start right now?
Yes, sir.
Yes.
Yes.
Okay.
Good afternoon.
Start
Yes.
right. Yeah.
Yes. Good afternoon, everyone. Yeah, I am going to present about the carbon nitrogen based organic semiconductor photocatalyst for photooxidation and CC coupling. This is an approach to sustainable chemistry. So, what is the photocatalysis? The photocatalysis, that is the irradiations of the um, light. Okay, means we are considering the visible light. That means the wavelength varies from 380 to 780 nanometers, and the energy is 380 to 154 kilojoule per mole. So the photocatalysis is an alternative to the traditional thermochemical catalysis. So it is based on the use of semiconductor materials, and it has the potential to facilitate the chemical synthesis under milder and environmentally friendly conditions. So recently, the employability of the 2D semiconductor graphite carbon nitride as a metal-free photocatalyst with band gap of 2.76 electron volt has attractive interest due to its earth orbital elemental compositions. This can be easily synthesized from the inexpensive precursors. This is the appropriate electronic configurations. This is innate thermal, chemical, and photochemical stability. So it is the catalytic efficiency, is lower toxicity, and it has the more advantages of the graphite carbon nitride is the separations by centrifugations or by filtrations. So the graphite carbon nitride can also be tunable according to the doping of different non-metals or other metals. Okay, so we have used this graphite carbon nitride, that is the metal-free catalyst, for the photooxidation and CC coupling. So I have divided this our work into three categories. It is a part one. We have shown that the photooxidations of the benzyl halide to the aryl acids and the degenerated byproducts can be further utilized for the other reactions. Okay, so in one part we can synthesize the two products using the shaft of sunlight and using the recyclable catalyst graphite carbon nitrides. And I will discuss about further the more, and let's discuss about the part two. So in the part two, we have also used the milder and greener visible light and graphite carbon nitride for the photo decarboxylative oxidations. And in part, we have shown that we have synthesized a number of 3-hydroxy isononyl moiety containing scaffolds using the same catalyst, the graphite carbon nitride, and other variations of visible light. So first we discuss about the part one on that. So we have very optimized the reaction conditions using different types of catalysts synthesized at different temperatures and using different photocatalysts. That means the titanium, cadmium sulfide, and other homogeneous catalysts. So from the literature survey and our approach, we have seen that our approach, that is the heterogeneous visible light method catalysis, is excellent as compared to the other methods. So here is the in the first case, the degenerated byproduct hydrogen bromides can be reutilized for the synthesis of the alpha haloketones in one pot in the sunlight. So the mechanism of the reactions is that the under the irradiations of the sunlight, the substrate molecules get excited and it forms the aryl radicals. And here we have not used any external oxidants. The hydrogen peroxide is generated in situ and is sensitized to reactions and forms the photooxidized products. So in the second part also, we have synthesized a number of biologically active molecules in simple manners. So in the third part, we have seen that we have synthesized a number of pharmaceutical scaffolds containing 3-hydroxy benzyl moieties, as the 3-hydroxy benzyl moieties are the important scaffolds, as this can be dehydrated to the sorry it can be dehydrated to 3-methyl isondylyl moiety, or it can be deoxygenated to 3-hydroxy isoindolylence moiety, as these are important in the pharmaceutical industry. So in a simple methods, we have synthesized a number of pharmaceutical agents molecules. So after that, we have tested the recyclability of the catalyst. So we have seen that after the 7 times of reactions, we have seen that the physical properties of the catalyst is same as in the starting. So from the excited.
Your time is up.
Okay, okay, sorry, yes, sir. One minute, sir. So from the recycling test, we have seen that the physical properties of the catalyst is same as in the starting. So you can easily say that this is the good catalyst for the photo reactions in a sustainable way. Okay, so thank you.
Any question?
I have a small question. So, have you done any scavenger studies to identify that the electrons are actually responsible for this
No, actually,
catalysis?
yes, we have done a number of control experiment, and we have used um, the electron scavenging compound, and we have seen that in presence of the electron scavenging compounds, the reactions is substantially decreased. So, and we have also tried using the different whole scavenging molecules, and we have seen that the reactions is drastically decreases. So from these control experiments, we have clear that there is the presence of hole and electrons in the reaction medium.
Okay. Any more question?
I can maybe ask one more. I can see the how you are drawing the how the electron is actually getting involved in the reaction, but what is taking the hole? That is not very clear to me. Like where the hole is actually going. Maybe it's there. I missed it somehow.
Yes, it's true actually. When the photocatalyst is irradiated by the surge of sunlight, actually we generally use the sunlight, or to standardize the condition use the blue light. It means 450 to 455 nanometers. Okay, so when we only use the static material and there is no irradiations of sunlight or visible light, so there is no reactions actually. But so by irradiations of the visible light, the graphite carbonites get excited. Okay, so it can easily generate electrons, but the substrates which has the more electron, also it has the ability to accept one hole from the graphite carbonites, and it can generate the hole, and the extra generated electrons can be transferred to the graphite carbonates, and it can be further generated for the peroxide radical formations.
Okay, thank you.
Yeah, thank you, sir.
Any other question? I think no more. So, okay, thank you, Sangeeta. Let's.
Thank you, sir.
इधर तो समझ में नहीं आई, ये कोई डर भी नहीं है, ये तो बस पता नहीं इन लोग क्या अप्लाई के अंदर
Please mute, please mute, please mute, please mute. Yeah, so I need to close this one. This. Give me some time. I have to share separately few slides they have shared with different sites.
So there are a few presenters who are absent in the first session. Are they going to present it now?
Yeah,
Or?
no, there are a few more is there actually, 3, 4 is there. I just need to. So next presentation is by Sottam Saurabh. Ankita Bhatia, please mute your mic. Hello, Sottam Saurabh is around? Hello, I am audible?
Yes,
Hello.
yes.
Yeah, I can hear you.
So Sottam Saurabh is not around, so I am going. I am calling Soham Chandra. Is he around?
Yes, I am there. I am here.
Okay. So so let me share your presentation. So I need to close this one because you people send me in the different fashion. I don't know. I told you. Soham Chandra.
Actually, I had sent a PDF version of my presentation.
No, we require actually PPT version so that it is online, na? Okay, no problem. Screen is visible, right?
The screen is visible.
Go.
Can it be made a full screen?
Uh,
Okay, shall I start now?
No. Krishnaka, what I need to do? Control L. Yeah. Yeah, go ahead. So,
Excellent. Excellent. The Department of Physics, Presidency. I hope I am audible, right?
Yeah.
Okay. So good afternoon, everyone. I am Soham Chandra from the Department of Physics, Presidency University, Kolkata. Today, I would be discussing about effects of
You are not audible.
dilution on compensation in easing spin half layered triangular shading magnets with non-planes. Really? Cannot you hear me now?
Yeah, yeah.
Hello?
Yeah, yeah.
Okay. Should I start from the very beginning? Didn't you hear anything from the first?
No, you go ahead. We listen something.
Okay.
Yeah.
Okay. So in recent years, thin magnetic materials in which one dimension is greatly reduced than the other two are of significant interest. The layered ferrimagnets among them show potential for magnetic refrigeration as they exhibit compensation point, which is a temperature below the critical point where total magnetization is zero, but individual layers are still magnetized. So the Metropolis Monte Carlo simulation is performed on a tri-layered ABA ferrimagnet like the one presented in figure 1. Here the red and blue balls are magnetic atoms with spin half, and white ones are the non-magnetic impurities with spin 0. The impurity concentration varies from 5% to 45% in steps, and each plane has linear dimension L equal to 100 in the actual simulation. So the nearest neighbor using interacting Hamiltonian is shown with zetas being probability of occupation by a magnetic atom at a site. So configurational average magnetization is obtained by summing magnetization of all the three layers and dividing by 3. Now, plot of the total magnetization versus temperature in figure 2 shows a shift of compensation point towards low temperature values with introduction of 20% non-magnetic impurities. See, for example, the purple line with JAB divided by JBB equal to minus 0.04. And for JAB divided by JBB equaling minus 0.52, that is the red curve, shows even a creation of compensation point compared to its pristine counterpart after the introduction of site dilution. Profiles change from Q to A via R. As we increase in C, the maxima of fluctuation of associative energy per site shift under the influence of site dilution. In figure 5 shows how the compensation temperature behaves under the variation of either the ferromagnetic coupling ratio, that is JAA divided by JBB, or the antiferromagnetic coupling ratio, that is JAB divided by JBB, keeping the other coupling strength fixed. Figure 6 is a technical procedure of detecting the critical temperature by the global maxima of Binder's fourth order magnetization cumulant. Finally, in figure 7, increase the concentration of impurity, the area where no compensation is present shrinks further and further, and a linear phase 0.002, above which we should expect to find no compensation for the available coupling strengths in this experiment. So with this, I would like to thank UGC. Some questions if one wants to ask. Thank you.
First of all, your network is very poor. Okay.
Okay.
Yeah. So, question from judges.
Shoham, what is the necessity of calculating the Binder cumulant?
Well, sir, actually, when one wants to detect the critical temperature of a magnetic system, what happens is that there are finite size effects in the system. So to actually eliminate the finite size effects and to find the critical temperature for a truly infinite system that is in the thermodynamic limit, we always need to have some procedure to eliminate the finite size effects. Binder cumulant is actually one of them.
And why? I mean, why is it so? What is the unique feature of the Binder cumulant that it will show? I mean, what is it that you're measuring in the Binder cumulant?
Exactly. For example, see in the figure 6, what happens is that when the system passes through the transition point, the Binder cumulant jumps from 0 to a finite positive value. Here it is 0.66 going on.
Hello.
Actually, So at that point, I should not call. Can you hear me?
Yes,
Hello?
I can hear you now. I can hear you now.
Hello.
Hello.
Okay. So as one goes through the transition point, what happens is that the Binder cumulant jumps from 0 to a finite positive value. So when one wants to actually plot dUL dt, that is the first order derivative with respect to temperature, one can expect to see a dip. That dip is in figure 6b. So that is an indication where the transition actually takes place.
No, I understand. I'm saying that what is the definition of this UL? What is UL?
Okay. Now I get it. So this is basically 1 minus m to the power 4 configurational average divided by 3 m square configurational average.
Okay.
So actually limitingly it would go to 2/3 when actually the magnetic ordering has taken place. That is actually 1 minus 1/3. Okay. So that value is obtained in the ferromagnetic region, or rather in the magnetic region, I should say. I mean, when actually we are dealing with mixed magnetic interactions, one cannot say whether it is ferromagnet or antiferromagnet. Rather, it is a ferrimagnetic system that I am dealing with in this study.
Correct. Okay. Thank you.
Thanks a lot. And I would like to, at last, I would like to thank Science Dialectica for providing me this wonderful platform. Wish you all to have a good day ahead.
Thank you, Soham. Thank you. Any more questions? No. So, so our next presenter is Sifali Hafiz. Sifali Hafiz.
Yes, sir.
Yeah. Okay.
Yes, sir.
Let me share your. So my slide is visible, right?
Yes, sir. It's visible.
Okay. So
Shall I start, sir?
Yeah. You start.
Good afternoon to all the gathering. This is Shafali Hafiz from Department of Zoology, Aligarh Muslim University. Today I'm here to present my topic on salinity-induced plasma osmolality, hormonal and enzymatic alterations in steamer-haline freshwater catfish, Claris batrachus. Beginning with the introduction, changes in homeostasis directly and indirectly by changing environmental conditions leads to stress in fishes. Among various abiotic factors, salinity is a critical factor for fishes because it influences metabolism through osmoregulation. Salinity induces modulation in stress-related hormones, stimulation of energy metabolism, electrolyte equilibrium and growth. The physiological disturbances due to the fluctuation in salinity are primarily studied by cortisol and thyroxine measurement, and alteration in ion uptake regulation mechanism in fish induced by salinity is determined by plasma osmolality levels, and this adaptability is dynamic with greater availability of osmotic ions in the water. Also, sodium potassium ATPase and succinic dehydrogenase activities has been extensively used as a biomarker in fishes for seawater acclimation. Coming to my specimen chosen, that is Claris batrachus, it's commonly known as markhor. It is usually found in ponds, rivers, and ditches. It's easily maintained in laboratory conditions, so voracious feeder. And coming to the experimental design followed. Firstly, the fishes were procured from the local fish market of Aligarh, and they were acclimatized for 4 weeks to the lab conditions. And then they were divided into 3 groups. The group first was control, and the remaining 2 groups were set for 30% seawater and 35% seawater. That seawater was prepared under the lab conditions, and later for at a 24 hours time point and 3 days and 6 days time point, the blood was collected for plasma osmolality, plasma cortisol, and thyroxine measurements, and gill and kidney were dissected for sodium potassium ATPase and SDH activities. The parameters analyzed were done from the following methods were followed. For cortisol was done by the cortisol reactant, thyroxine by Wisdom and Walker method. Plasma osmolality was done by vapor pressure osmometer, and sodium potassium ATPase was done by Evans et al. And succinic dehydrogenase was done by method of Pennington. The results of my study is as follows. The plasma cortisol showed a decreasing trend at all the 3 time points, 24 hours, 3 days, and 6 days. And while in case of thyroxine, there is an increasing trend for at all the 3 time points of both the highest salinities, that is 30% and 35% seawater. While in case of plasma osmolality, we can see an increasing trend at all the 3 time points. And in case of sodium potassium ATPase GIL, there is no significant increase at all the 3 time points, whereas in sodium potassium ATPase kidney, there is a significant increase at both the salinities, that is 30% seawater as well as 35% seawater. Whereas in GIL kidney SDH, there is no significant increase at all the 3 time points, whereas in GIL SDH there is an increasing trend has been shown at all the 3 time points. This can be concluded by this, that cortisol is classically viewed as seawater adapting hormone, whereas and also thyroid hormones can be envisaged to be jointly in control of the mobilization of energy to fuel osmoregulatory processes. They both are showing the inverse relationship. Cortisol is showing a decreasing trend, whereas thyroxine is showing an increasing trend. So this interaction can be suggested in this way, that between these two hormones, they help in the osmoionic adjustment of the fish. The adjustment period in higher salinities immediately follows the transfer from fresh water to seawater, and is characterized by the alteration in the plasma osmolality. Different hormones control the activities of the organs involved in osmoregulation, which maintain water and mineral balance in different salinity. Thus, conditions that affect or disrupt the ionic homeostasis cause change in hormonal levels involved in osmoregulation as a response to control the ion transport capacity. But whereas in case of sodium potassium ATPase and SDH, we can see a modifying response in both the tissues, gill and kidney activities towards different salinities have been observed, suggesting adaptation mechanism of fish in changing environmental conditions. These are the references. Thank you.
Yeah.
So I have a question, Shifali. So you have done your experiment with catfish, right?
Yes, sir.
But do you think is there any? Well, my question is that with different kind of fishes, is the adaptability will change, or so how is the adaptability with different
So basically,
fish?
I have done this experiment on catfish because it is a hardy fish. So it can just it can just adapt itself to a wider salinity conditions or any other stress given to it, whether it will be a handling stress, whether it should be a transportation stress, or some salinity stress, or some biotic or abiotic stress. So I just chose it because it's a hardy in nature.
Okay.
But there are furthermore studies.
Yes, go ahead. Go ahead.
There are furthermore studies where work has been done on some other fishes, and they have shown different results at a different salinity stress.
So you have used freshwater kind of fish. So what about saltwater fishes? So catfish is basically a sweetwater fish, right?
Yes, sir. It's a freshwater fish. Yes, sir.
Yeah, freshwater. So so why not you have used some saltwater fish or
maybe in future, but this time I just performed my work on the fresh. I just want to see how if we will transfer freshwater fish to seawater fish, how it will work and how it will respond to the salinity stress, so that in future it will help the aquaculturists to perform the studies around the globe. Salinization is rising in all the water bodies, and our flora and fauna both are being affected by that salinization. So that
okay.
is why I just conducted this experiment.
Thank you. Thank you.
Thank you so much.
Any other question?
Can you please? Sorry. Go ahead.
I had a small question. Do you have any idea what kind of salinity normally the estuaries have?
35 ppm. That is
So
35
I
parts
mean,
per thousand.
okay. So I mean, coming to your study, do you think that this kind of freshwater fish has the adaptability in those kind of conditions?
No, sir. It can't resist that much of, because 35. Yes, sir, it can, because 35 ppt is equivalent to 3.5% of salinity. But I have performed this experiment in 35% and 30% salinity.
Okay. Yeah, actually, I asked because in Sundarbans there are some kind of catfishes that are present. In that point of view, I just asked the question. Thank you so much.
Sagar, quick.
Yeah. So can you please again comment on the inverse relationship that you have observed? Like
Basically, some other studies have shown that basically cortisol is a seawater adaptation hormone. So its decrease is normal in this condition. But some studies have shown that thyroxine does not show increase. But here in my fish, both have shown cortisol has shown a decreasing trend at all the 3 time points, whereas thyroxine has shown an increase at all the 3 time points at both the salinities, 30% and 35%. So it is I just think that they are showing both the hormones are showing an interaction for the osmoionic adjustment, so that the fish can adapt in those higher salinities. Sorry.
okay, thank you. Mhm.
Okay, so I think I need to move to the next one. Okay, thank you, Sepali.
Thank you.
So our next presenter will be Jeshan.
Yes, hello, sir.
Yeah, I can see you. Yeah, from tomorrow I can see you. Okay.
Am I audible, sir?
Yes. Just let me share yours.
Okay, fine. Okay, take your time. Okay, shall I start now, sir?
Yeah.
Okay, good afternoon to everyone present in the group. My name is Zishan Umar Shah. I'm a research scholar from Limnology Research Laboratory, Department of Zoology, Aligarh Muslim University. See, my topic is oxidative biochemical and histopathological alterations in fishes from pesticide-contaminated River Ganga, India. As we know, pesticide pollution is a global concern. India is one of the largest producer and consumer of pesticides. On an approximate, more than 500 different formulations are present in the market. After application of these pesticides in the agricultural areas, their residues tend to persist in the environment for a longer duration, having an impact on non-target organisms. River Ganga is the second largest river of the India, having great importance of religious as well as is a source of economy and provides nutrition to the local population. The biogeographical structure of this river has highly changed over past by a large scale of agricultural activities on its basin. On an approximate, more than 2,100 metric tons of pesticides are annually used in agricultural areas along the basin. After application, the residues present in the fields gets concentrated in this river by different means, that may be surface runoff, that may be leaching or drainage from the agricultural areas, thus having impact on the non-target organisms. In my preliminary studies, I have found different pesticides in the water samples collected from different stations of the River Ganga, and also in the fish tissues that were also collected from different stations of the river that I have published in Toxicology Reports Journal to find out the possible impact of these pesticides present in that I found in the fish tissues. I have done histological studies and oxidative biomarker studies in two most commonly consumed fishes from the river, that is Rita Rita and Cyprinus scorpio. And samples were collected from three different stations: Rishikesh Station, Narora Station, and Patna Station. Rishikesh Station is present in Uttarakhand state, and Narora Station is present in UP state, and Patna Station is present in Bihar state. Coming to the histological studies of the fish Rita Rita and Cyprinus scorpio. The first two plates shows the gill tissue of Rita Rita from Rishikesh Station. The gill tissue shows dilated vessel. Focal area in the second plate shows lamellar fusion and disruption. This plate C and D shows gill tissue of fish Rita Rita from Narora Station, showing sloughing of lamellar epithelium and their disruption, dilated vessels, lamellar congestion. Gill tissue of fish in the E and F plate show Rita Rita from Patna Station shows smooth muscle hypertrophy, gill bridging, hemorrhage, and swollen lamellae. The gill tissue of fish Cyprinus scorpio from the Rishikesh Station shows sloughing of lamellar epithelium and their disruption, dilated vessels. Gill tissue of fish Cyprinus scorpio from Narora Station shows lamellar epithelium and their disruption, lamellar congestion, disruption of lamellar epithelium, smooth muscle hypertrophy. Gill tissue of fish Cyprinus scorpio from Patna Station shows gill hyperplasia, smooth muscle hypertrophy, sloughing of lamellar epithelium and their disruption. Smooth muscle hypertrophy were also found in the examined slides. The liver tissue of fish Rita Rita from Rishikesh Station shows vacuolation in hepatocytes. The liver tissue of fish Rita Rita from Narora Station shows focal lymphocyte and macrophage infiltration. Liver tissue of fish Rita Rita from Patna Station shows necrotic change in hepatocytes, vacuolation in hepatocytes, rupture of vein, pynotic nuclei, melanomacrophages were observed, distorted arterial wall were observed. The liver tissue of a fish Cyprinus scorpio from Rishikesh Station shows vacuolation in hepatocytes. Liver tissue of fish Cyprinus scorpio from Narora Station shows lymphocyte and macrophage infiltration. Gill tissue of fish liver tissue of fish Cyprinus scorpio from Patna Station shows hepatocytes, necrotic change in hepatocytes, pynotic nuclei, rupture of vein. The next study was done on biomarkers. Oxidative stress biomarkers are the main indicators of fish health. The oxidative damage caused by pesticides.
Your time is up. Yeah.
Okay, just a second. Just 1 minute. The gill catalase activity of both fishes, Rita Rita and Cyprinus scorpio, shows significant increase at both Narora and Patna stations compared to Rishikesh Station. Similar results were observed in another fish, Cyprinus scorpio. The SOD activity of both fishes, Rita Rita and Cyprinus scorpio, shows significant increase at Narora and Patna stations compared to Rishikesh Station. Similar results were observed for SOD activity and protein carbonyl concentration. To conclude my work, fishes collected from Narora and Patna stations show large scale of histological damage and oxidative stress than Rishikesh Station. This could be due to the difference in usage of and accumulation of pesticides. Furthermore, out of the two fishes, Rita Rita shows more damage than Cyprinus scorpio. This might be due to the high fat content and difference in excretion of physiology of the two fishes. Thank you, sir.
Hi, Jishan. I have just one question. So you have chosen Rishikesh, Narora, and Patna.
Patna Station, yes, sir.
So what is the reason of choosing three specific regions?
Actually, sir, there is a difference in usage of pesticides in the three states of River Ganga states.
I can't understand. Can you just repeat one?
Actually, there's a difference in usage of total amount usage of pesticides in the 3 different regions, sir.
So how do you know that? This is some data.
So actually, yes, the data is present in the agricultural website from Government of India, sir.
Okay. Thank you.
So, what is the common name of these fishes?
Yes, sir. Rita and common carp.
So Rita is
Rita.
Rita, jo hai. Okay.
Yes,
okay.
sir.
And other one, what you said? What is the fish?
Common carp is the common name, but in India
Common
it
carp.
is called
So
as
it
golden.
What we call
golden.
rohu basically.
No, that is different. That is labio rohita.
Okay. So both are consumed also.
Yes, sir. Both are consumed and present in local markets also.
So you have also seen, deposition or direct deposition of these harmful chemicals in the fishes.
Yes, sir.
So those
Okay.
things you are also checking. Okay. Yes, Shoral?
Yeah, so we need to move. Yeah.
Okay.
Any other question from?
I don't think.
Okay, thank you.
Yeah, thank you, Jason. Thank you.
Okay, thank you, sir.
So there are 2 more presentations are there. Maybe you will not find in your Excel sheet. I can share from Swati Sharma is around. Swati Sharma is around. I can see her. Rimpa from BARC. Rimpa.
Yes, sir. Yes, sir.
Okay. So are you ready, right? Okay. Let me share your PPT. Yeah.
Just a minute. Just clarification. So these names are not in our list, right?
No.
So I have to. Okay, I understand.
I forgot to put these 2.
Okay. Rimpa Jaiswal. Okay.
Yeah.
Yes, sir.
After this, there is one more. Then it's final. Okay. So carry on.
Good afternoon to everyone. Thank you for giving me an opportunity to present my research work. I am working as a research associate at BRC, Mumbai. And today I am presenting a probing of bile salt aggregation using a fluorogenic probe GEM DNS sodium cholate complexes. First of all, the detection and quantification of liver, which is associated with diagnosis of many diseases, we use a fluorogenic spectroscopy for the quantification and detection in selective and very fast manners. That's why we are choosing GEM DNS sodium cholate complex for our applications. Gemcitabine, that is a GEM, which is most usually known as a anti-cancerous drug, but there is some toxicity and deamination of amine in the biological system. Its application is limited. That's why we have derivatized it with densyl fluoride, that is a DNS. And when we taken this GEM DNS as a probing agent in presence of sodium cholate, it's giving a very selective and in a very fast manner a good response towards the fluorescence. First, I have checked emission spectra in presence of sodium cholate, and initially, as we know that GEM DNS in the free state, in absence of any host molecule, it is very free to rotate and twisted. That's why it's showing the very weak emission through the intramolecular intramolecular charge transfer, as well as in excited state dissipate its energy. But in the presence of sodium chlorate, its decay is diminished because its free rotation is restricted. This figure 1 is showing that as we increase the concentration of sodium chlorate, the intensity is increases. And this is showing that this dye, that is a GEM-DNS, is working as a dye which incorporated inside the sodium chlorate and as forming a micelle. And as the concentration of sodium chlorate is increases, its intensity is increases. And further, we have taken its non-linear fitting, which also showing that its intensity is increases on increasing the concentration of sodium chlorate, which confirm that the incorporation of GEM-DNS inside the sodium chlorate. And we further tested its temperature effects on GEM-DNS sodium chlorate complexes. As we found that as the temperature is increases, its intensity is decreases, because this micelle which is formed is now broken, and GEM-DNS is released outside of the sodium chlorate. That's why there is again weak emissive transition charge transfer will take place, and doing the dissipation of energy. And further, we investigate its excited state lifetime and anisotropy measurements by using time correlated single photon spectroscopy. And from this, we have found that initially, as we say that GEM-DNS in the free state is a very is free for rotation, and there is a charge transfer, intramolecular charge transfer will take place. But after incorporation with the sodium chlorate molecules, it restricts its flexibility, and due to this restricted flexibility, it's become a rigid, and it increases the lifespan, that is a decrease, it's a decay point. And further, we have proof it from the anisotropy application, and we found that again it is showing the decrease in its decay constants on applying the sodium cholates. And on behalf of these results, we have found that the sodium cholate in presence of GEM-DNS dye, from this we can selectively and readily investigate any molecule inside the biomolecules or inside the biomedia by using the fluorescence spectroscopy. Thank you, sir.
Question? Any question?
Can you please comment on the anisotropy decay once more, like the on your figure 5?
Yes, sir. In figure 5, initially, in absence of sodium cholate, GEM-DNS was showing the free rotations, and there is intramolecular charge transfer that take place, and this intramolecular charge transfer facilitate the dissipation of energy. But in the presence of sodium cholate, which trigger out this dye, and in that case, the excited state decay is a slowdown, and the lifespan is a slowdown, as we saw in a red line. That's confirmed that there is a triggering of this particular dye inside the sodium cholate.
Okay. And one more small thing, that in this figure 5 for the trace 1, the blue one,
Yes,
so do you fit it by single exponential or?
Is a single exponential, sir.
Okay. Thanks.
Okay, thank you, sir.
I have a question. So there is a hypsochromic shift in your emission spectra I've seen. So
Yes, sir. There is a blue shift in
Yeah,
the emission spectra.
yeah, so what is the reason? Can you just explain one more time?
The reason is behind that, sir, there is a charge transfer is take place, and again in the presence of sodium folate, the de-excitation of energy state is will take place in non-radiative manner. So that's why it is shifted toward the blue region.
Okay, thank you.
Okay, thank you, sir.
Okay, I will not take any question, so I need to move to the next one.
Thank you. Thank you.
Thank you, Rimpa.
Thank you, sir.
May I call Swati again? Swati is around. Swati Sharma. Okay. Yes, Paul.
Yes, sir.
Okay. So let me share your. I need to find your slide.
Okay, sir.
Shoramda.
Yes.
This Swati Sharma, she already presented.
Oh, is she? Okay. Okay, then the just last one, this one.
Okay.
Yes. Yeah.
Okay.
Go ahead.
Good evening, everyone. So today I am going to present a poster on my topic, spirulina acting as a surface assimilative on heavy metals present in the water. So the main objective of the study is to extract the heavy metals from the wastewater and make the wastewater usable and usable. So first of all, we will see that what is spirulina. So it is a cyanobacterial species which floats on the water. It contains polysaccharides, lipids, and vitamins with a many functional group like carboxyl, hydroxyl, which help in metal binding. So now I will introduce you to my topic. So as we all know, spirulina is a cyanobacteria. So it can synthesize the metal binding protein known as metallothionein. So the heavy metals present in the water bodies are of two types, essential and non-essential. So essential metals are zinc, copper, and non-essential metals are chromium, mercury, and lead. So the increasing these non-essential metals are increasing due to the waste generated by the e-waste and industrial processes like stabilizer and agricultural activities such as pesticides and fungicides. So we have made a model. So this is the diagrammatic presentation of our model, which will help to extract the heavy metals from the wastewater with the help of spirulina. So now we will see how it works. So first of all, we will add 0.12 normal HCl in a spirulina of about 100 gram in 1 liter of water. Then we will washing it with a distilled water and air dry it. Now we will get a dried and crushed spirulina. So in next step, we will add the 100 ml of toxic wastewater and into a rotatory flask at 150 RPM for 1 hour. So at last, we will get the supernatant, which will be filtered by the Watson paper 40 number 42, and this will be this sample will be checked by the gas chromatography, the presence of chromium. So now we will see the mechanism of our model on which the model works. So cyanobacteria synthesize a metal binding protein metallothionein. This protein rich in the cysteine residue. So this cysteine residue bind with the zinc and chromium and the cysteine-thiolate bridge is formed between the cysteine and zinc and the chromium. So the synthesis of MTS elevates when the metal when the heavy metal concentrations is higher in water. So in a methodology, I have collected my primary data from the Google survey form on the e-waste management and its awareness in the residents of Mumbai, because the e-waste is the leading reason for increasing heavy metals in water and environment. So the secondary data is collected by referencing the research papers available on the Google. The survey results show that about 76% people are aware about e-waste, but they are still not practicing any e-waste management, and about 66% people are throwing the old electronic devices directly into this trash. About 60% people are ready to pay and practice the e-waste management. The above study concludes that there is a need to spread more awareness about e-waste in the residents of Mumbai to reduce the e-waste and water pollution. Several studies shows that approximately 80.9% of heavy metals get removed with help of spirulina, which is the most feasible method for extracting the heavy metals. At last, there are my references. Thank you so much, everyone, for your valuable time. Thank you so much. Any questions?
Yeah, question.
I can ask maybe. So first of all, this model that you have shown, so have you manufactured it already, or it's just a proposal?
No, sir, it's just a proposal. We are trying to manufacture it.
Okay. And second, these cyanobacteria, they are actually able to do photosynthesis, right?
Yes.
So yes. So when you are doing these treatments, so do you think that this their absorption of these heavy metals that will have any effect on their own survival, or like on the photosynthesis in a way, or like somehow mutate them?
Yeah, because it is having cysteine residues now, so it will bind with the heavy metals, and then it extracts it from the wastewater.
Yeah, but does it release the protein in the water to capture them, or they themselves, with the help of this protein, kind of uptake the chromium, and then that will lead to their own death?
No, sir, that will not lead to their own death, because shows that literature study shows that they are just extracting it into the water, and they are not get harmed by these heavy metals.
Okay, interesting. Thank you.
Okay, thank you, sir.
Any other question? If there is no more, so I need to close this session, and I need. Thank you. Yes, thank you. Yeah. So I have done my job. I think I must thank you to all presenters. They really did a good job, and really the nice presentation, almost 5 hours. So 11 to 4:30, yeah. So 5.5 hours. So it's really there are different kind of, it's a wide spectrum of presentations, right from 11 o'clock to 4:30. So yeah, I really enjoyed, and I must thank you to all the judges who judges their posters. I have no other words to except to say thank you. And okay, so my job is done. So I want to hand over my position to Dr. Sayan Bayon. He is recently working as assistant professor of Rajiv Gandhi University. It's basically Central University, Arunachal Pradesh. So before going to hand over to him, so I need to take a photograph of all the participants here. So may I request you all to kindly turn on your your webcam so that I can take a snapshot, or a screenshot, like, yeah. Please, fast. There are many more. May I request to all of you, please. I am tired. Judges are tired. Participants are tired, and the next presenters are also feeling tired because they are going to present. Yeah. Okay, let me take. Smile. Yeah, thank you.
Thank you very much.
Welcome, Shayan.
Thank you, sir.
Thank you, Dr. Saurabh. So we are now moving to our next session. So we have basically 5.
Shayan, I am interrupting you. Participants, please don't leave the floor, because your result will come up after the scientific session. So please be there. Okay. Yeah, I request you, please listen the next 3-4 lectures. There will be, I assure you, there will be good presentations are there. Okay, you can learn many things. Yeah, thank you.
Yeah, let me continue. So we have 5 invited speakers here with us, and they are going to talk on different aspects of science. And let me first introduce our first speaker, Professor Shiv Kumar Misro. Is from Indira Gandhi National Tribal University. He is an associate professor there, and Professor Misro had done his PhD from Allahabad University, and I was quite fortunate enough to get him at Shah Institute of Nuclear Physics for quite a few days. And from Shah Institute of Nuclear Physics, he moved to Lucknow University as a DS Kothari fellow. Then he joined, after that he joined Indira Gandhi National Tribal University, and he's continuing there, he's serving there. And his main research area is zinc oxide based optoelectronic devices. He has done a lot of works in photodetectors. We have a few papers in collaboration, and individually he has got more than 40 or 50 papers in different reputed journals and few book chapters also. So I will request him to start his presentation. Dr. Misro, it's over to you. So just I'd like to mention that you will be given 25 minutes where we'll have 5 minutes for discussion. So basically it can be 20 plus 5. Okay. I think you are muted.
Yeah, thank you, Dr. Sayan. We are quite late here, and actually network issue is very much here. We are in Amarkantak. It is a very holy place, and now 12 rivers are originating from Amarkantak. One of Narmada is very famous, and she is known as a daughter of Lord Shiva. So anyone can visit here. Lots of facilities are here. This is newly established university, and they're located in interior of Anuppur Jilla, district of Anuppur, Madhya Pradesh. So I would like to thanks for giving me opportunity in the second international conference on convergence of interdisciplinary sciences. and especially to organizing team and organizer, editor of Science Delecta, convener, editor Dr. Arunima Bandyopadhyay, and co-convener Manvita Basu, and my both friend, very close friend, Dr. Sayan and Dr. Saurabh. Both are with me at Science Institute of Nuclear Physics, and really I am feeling glad to see here on online mode. So I think it is visible. Sayan, it is visible?
Yeah, it's visible. Yeah, it's visible.
So it is a very informative lecture. I'm not going to deep inside. And my topic is the fabrication and characterization of zinc oxide nanostructures for photoreactor applications.
Dr. Mishra, please make it full screen.
Yeah, is it? Now it is done?
No, it's not in present full screen mode till now.
From my side, it is okay.
Other audience, can you?
Yeah.
Yeah. Now it's there. Now it's there. Yeah.
Right. Fine. Now.
Yeah. Now it's okay. Yeah.
So thank you, Sean, again. So my topic is the structure for photoreactor applications. So I'm just doing something to do something good in device applications. So the outline is very, small and fundamental. The fundamental of nanoscience and nanotechnology, zinc oxide nanostructures, and preparation based on zinc oxide based nanostructures, photoconductivity properties, photoreduction. Zinc oxide nanostructure finally conclude. So basically, the nanoscience and nanotechnology. So the discipline of nanoscience and nanotechnology has recently become important area of knowledge encompassing various scientific disciplines, including the physics, chemistry, and biology and engineering. This tremendous interest is mainly due to the two reasons. The first, the nanoscale materials have many prospects in various technology. Because most of the time they show novel functionalities. Secondly, there is a tremendous scope of creating new knowledge and explaining the size dependence of evolution of various physical properties, and in explaining new and previously unnoted or unnoticed features, etc. So the nanostructure materials can be utilized in fabricating novel active devices with the improved functionalities. The knowledge based on the nanoscience and technology has already reached the tremendous balloon to which now an idea being added. So today the widespread activity in the nanoscience technologies are actually noted in the ideas of some leading scientists of the last century. Among them, you are all familiar technology and material science. They are familiar with a very famous name, which is Richard P. Feynman. He delivered a legendary talk that is entitled "There is a Plenty of Room at the Bottom" in the annual general body meeting of the American Physical Society on December 29, 1959. At the California Institute of Technology. So in that talk, he discussed about the ideas of manipulating the controlling things at the atomic scales. So nanotechnology actually the principle of manipulation atom by atom. So the control of the structure of a matter at the molecular level. So it entails the ability to build a molecular systems with atom by atom, precisely yielding a varieties of nanomachines. Here we can see here refer to the control and manipulation, as we said, the matter of nanometer dimensions means 1 nanometer equal to 10 power nanometer size. So the origin of term nano, it comes from a Greek word for dwarf, but in a scientific jargon, nanomaterials or nano means 1 billionth. The 1 nanometer, I said 1 nanometer and 10 power minus 9 meter at a scale. So to indicate the smallness of any object, we often compare it with the human hair. To get the sense of nanoscale, the average diameter of a hair known hair is about 50,000 nanometers. So the term nanotechnology that employed to describe the creation and exploration of material with structural features in between those of atoms and the bulk material. So with at least one dimension nanometer is. So the properties of material and nanometer dimensions are significantly different from those of atoms as well as those of a bulk material. So one of the important thing in the nano size materials is important aspect is the quantum confinement effect. So it is a hypothetical model that is based on hypothetical mass approximation, and that has been proposed to explain this effect. So according to this model, quantum confinement effect can be of two types. So one is a strong confinement, other is a weak confinement. It is based on a Bohr external radius. So the strong confinement regimes, so the particle size of the material that is fabricated is less than the Bohr external radius. It results in the blue shift. You can see here the E proportional to 1 by R square. When the radius of particle is increases, now denominator will increase square times, and the ultimately E will decrease. I mean, E will, if the R is increased, the E will decrease. The R is reduced, so E will increase. So E signifies energy band gap. The band gap of the material will increase, and it also results in discreteness in a band because of overlapping of a wave function. So individual motion of electrons and holes are independently confined, that is, you can say, quantized. So size dependent of external energy that can be expressed by this simple formula equal to Eg plus C by R square, where E is a bulk band gap, C is given here, h cut square by x square by 2 mu equal to the constant, where R is the particle radius, and 1 by mu in the effective mass. It is also mu is also called the reduced mass of electron and hole pair, and this x and L is the root of Bessel's functions. Similarly, for a big confinement, so if the size of the particle, the fabricated particle is less than a Bohr external radius, you can see a large effect on a different kind of property, that is a optical property or electrical property or like that. So in case of big confinement, the particle size of the material is greater than the Bohr external radius. In this case, the external translational motions is confined, and the size dependence of energy of the external, it can be expressed on this equation. Here, E y is the external Rydberg energy. M equal to M is ME plus MH, already known, effective mass. Similarly, you can see, you can distinguish the different kind of material. In case of molecules, it is a LUMO and HUMO. Least unoccupied molecular orbit and highest occupied molecular orbits. In case of a nanomaterial, you can see here a band gap that is increased compared with the bulk material, and it has a discrete energy levels. If we talk about the bulk semiconductors, now it has a 2 valence and conduction band. Now the band gap is quite low. So in bulk case, if you are increasing the band gap, that means you are going towards the insulator. But in case of a nanomaterial, you are increasing the band gap, it means you are reducing the size of the particles. So the main effect of confinement is the blue shift. That is the proportional to the square of the particle radius. So electronic properties such as the electron-hole interactions are modified in that strong confinement region. So quantum confinement, that effect that causes an increase of the energy band gap, that is the blue shift, the splitting of the electronic state, as we have seen in the last figure, and the different density of state. So the differences between the electronic behavior of the bulk and the quantum confined low dimensional semiconductors are due to their differences in a density of states. Now you can see here the passing from the 3-dimensional to 2-dimensional, the density of state changes from continuous dependence, that is A and E proportional to E power half, to a step-like dependence, and the typical absorption features are different for the bulk and for the quantum Bell structure. So you can see a different structure, the 0-dimension, 1D, 2D, and 3-dimensional aspect. So now we have a different synthesis method. We are familiar, we are working in nanoscience and nanomaterials. We have a two method. One is the bottom-up method, other is the top-down method. In a bottom-up method, it is also known as a chemical method. So it refers to the buildup of a material from the bottom, atom by atoms, molecules by molecules, so cluster by clusters. You can see here the bottom-up look like this, and top-down I look like this. So top-down method means the technique involves starting with a block of material and by etching or milling it down to the desired shape. So in this method, it is essential to convert a coarse grain polycrystalline sample into nanocrystalline form. So it is a very conventional, very expensive technique. It is also called a physical method. Molecular beam epitaxy and so many methods are there. So bottom up is a very easy method, and we can see here the bottom up involves the assembly of smaller subunits, atoms or molecules to make a larger structure. So we have a different bottom up approach. We have done already so many methods: co-precipitation methods, Solzel methods, hydrothermal methods, salvothermal method, thermal decomposition method, chemical vapor deposition method, biometric control, aerosol, and gas phase. So the different type of bottom up approach we have seen here. And for a zinc oxide, Solgel is a very appropriate, even hydrothermal is a very appropriate. So the challenges of bottom up fabrication is what? So getting the structure to grow exactly how and where you want. Making complicated patterns, fabricating robust structures. So advantage of this method is using this method, high purity uniformity, small particle size, narrow size distributions, good dispersals, good chemical homogeneity, structure composition uniformity, inexpensive mass scale. Solid-state reaction, one of the important methods is solid-state and thermal decomposition method, which is inexpensive and very mass scale productive method. So zinc oxide, as you are familiar with the zinc oxide is a it is that kind of wide bandgap material, a compound semiconductor that has attracted to scientific community and researchers as a promising semiconductor materials because of their wide bandgap, around 3.37 electron volt, and high external binding energy, 60 MeV. So it has a variety of practical applications, including transparent conductive materials, thin film gas sensors, barristers, photoconductive devices like photodetector or photoconductors, photo response, and different luminescence studies. One of the luminescence studies of zinc oxide particles are quite interesting. And because of its application in electrophotography and detectors of oxidizing and reducing agent is a very important. And this is a zinc oxide borazite structures and zinc blend structures you can see here. So one of the important parameters for a photodetector is the photoconductivity. What is the photoconductivity? It is simply important electrical conductivity. The increase in electrical conductivity that causes by the generation of additional free charge carrier by light of sufficiently high energy in semiconductors and insulator. That is termed as the photoconductivity. So in other words, we can say the number of electrons and holes increases by absorption of radiation in photoconductive materials. So as a result, the conductivity increases. Effectively, as a radiation controlled electrical resistance, a photoconductor can be used for a variety of light and particle detection applications as well as a light control switches. So we have a different type of photoconductivity. One is the intrinsic photoconductivity, that comes from the absorption across the primary band gap that creates the electron and hole photocarriers. The other is the extrinsic photoconductivity, that is the absorption from or to the impurity sites in a band gap that creates a photocarrier in a conduction or a valence band. So you can see here intrinsic photoconductivity, and you can see the band gap of extrinsic photoconductivity. So donor level to conduction level, you can see here, this represents a 1 and valence band 2, the acceptor level that represent to. Now hole will go to here and electron will go to the conduction band. So the application of photoconductivity, we have lots of application of photoconductive material, the photoresistor or photoconductive cell, or LDR also, the infrared detectors, UV detectors, missile detection systems, photocopiers, LIDARs, and 3D imagings. And the photoconductivity study that provides substantial information about the electronic transitions in a semiconductor. So in case of homogeneous material, the density of holes and electrons are uniform throughout the material. So in the insulator, the values of N and P may be much larger than the corresponding free carrier density in a dark. So in a semiconductor, the reverse is often true. And the effect of radiation can be considered as a small perturbation on a large dark carrier density. The photoconductivity actually can result from the second mechanism involving the reduction of the resistance of barrier by radiation in the non-homogeneous materials in which N and P are not uniform throughout the material. So different parameters we have that control the photocurrent in a photodetector or a photoconductive material, and that is the dependence of photoconductivity response. One is the field response, other is the where the voltage is applying. Now current we results the current, and similarly intensity response, intensity versus the photo and direct current, and with that is the time resolved rise and decay of photocurrent response, spectral response, and some temperature response. So from the dependence of photoconductivity on a factor such as the exciting photon energy, the intensity of the illumination or the ambient temperature, significant information can be derived on the distribution of electronic states in a material and on carrier generation and recombination processes. So as a photodetector, you can see here a voltage dependence of photocurrent. It is a voltage current voltage characteristic, a voltage current characteristic. It is a IV characteristic. You can see here when a voltage increases, it is on a logarithmic scale. When voltage increases, this is due to the under the dark current, this is under the illumination. So you can see it has a two slopes. Up to here, now the slopes is less than 1. Now up to here, the slopes is greater than 1. So this, if the slope of this spectrum is less than 1, it is called a sublinear behavior. You can see the current voltage characteristic in case of zinc oxide 9 nanoparticles under the illumination. This you have seen. So on a log scale curve, the straight line having a different slope with respect to varying voltage according to Power's law. That's called the Power's law, where IP proportional to big power R, where R is represent the slope of different straight line segments and different for lower and higher voltage up curves that increases with the increasing of voltages. So we can say here if slope less than.
Sorry to interrupt you, Dr. Mishra. Please, you have last 5 minutes.
So if slope less than 1, it is called a nonlinear variation of current. This is sublinear behavior. 1, this is a ohmic behavior. If greater than 1, it is non-ohmic behavior of photocurrent. Similarly, if it is a 2, slope is greater than 2, this shows that the current flow through the system is limited by a space charge at these voltage regions. So the current flow through an insulator is limited by a space charge when carrier is excess of those present in thermal equilibrium, and it can be injected through the contact. So you can see intensity behavior, intensity dependence of photocurrent. Now intensity we are increasing at different level, different lux. So now current will increase. Similarly, similar manner you can say here, if the slope is greater than 1, it is a superlinear behavior. Light intensity, electron permeable and hole permeable are shifted towards the direction. So the conversion of some of the class second states into the combination centers ultimately sensitize the samples. Similarly, for slope 1 and slope that is equal to 1, linear behavior, slope less than 1, this is sublinear behavior. So this is the rise and decay photocurrent spectra. This is some kind of device we have used to measure the photocurrent. This is the rise and decay curve when light is on. Now photocurrent will increase. It is have two process. One is a surface, fast process, the other is a slow process. And the rise and decay response that can help the study of photoconductivity dynamics. So the slow rise and decay response may be attributed to large amount of recombination centers and the presence of trap levels and defective state in a band gap. And we have used to determine the energy depth or trap depth. So trap depth is calculated using the following equation, that is the probability of an electron escaping from a trap is also governed by this equation, the P equal to S e power minus E by KT. That is called Randon-Wilkins for inputting a traps. And that is given by E equal to KT log S log E log E power I by I naught by I by T, where E denotes the trap depth, K is the Boltzmann constant. Now, parameters are given here. And this is energy of illumination, wavelength versus photocurrent. So the at the band gap levels, at the level of absorption, now it will be high in case of a zinc oxide in a UV region, and now visible region, now the photocurrent is quite slow. So the wavelength corresponding to band gap of material that produces a maximum photoexcitations, and thus the peak of the spectral response curves may correspond to the absorption edge of the sample. And in this higher wavelength region, the photosensitivity can be associated with the imperfection center in the layer. You can see here with a different region, 400 to 500, we have taken here. This is some kind of zinc oxide wave photodetectors. One is a photoconductor, other is a photodiode. So the photoconductor, zinc oxide wave, a photoconductor. The photoconductor actually consisting of a semiconductors with the two ohmic contacts. It essentially a radiation sensitive resistors. You can see here a schematic here. Now you can see for metal semiconductor, metal photodiodes, and in the past few years, metal photodiodes have become increasingly popular in the research field due to their fundamental advantages. And one is the simple structures, other is the ease of fabrications and the integrations, other is the low capacitance per unit area. So MSM photodiodes are comprised of two back-to-back Schottky diodes by using integrated interdistributed electrodes. You can see here configuration on top of active light collection regions. So schematic image of the MSM photodiodes you can see here, and the third one is the Schottky photodiodes. In Schottky photodiode, it's comparing with the photoconductor and MSM photodiodes. A Schottky photodiode has many advantages in the aspects of high quantum efficiency, high response speeds, low dark current, high UV visible contrast, and possible zero bias operations. The schematic structure of operations you can see here, and basically in ultraviolet photodetectors, it is based on a 5S. 5S means high sensitivity, high signal to noise ratio, excellent spectrum selectivity, fast speed, and great stability. So totally it depends on the 5S parameters. So PN junction, the next one is a PN junction photodiode, and PN junction photodiode is just a P and N junction diode that has been specially fabricated and encapsulated to permit light penetration into the vicinity, you can see here, of the metallurgical junctions. P, either it is a PN or it is a PIN, pin photodiode, have an advantage of fast responding speeds, low dark current, and working without applied biases. So therefore, PN and PIN, pin photodiodes, are the most suitable choice for future space applications. Now, photoconductivity is further governed by morphology, surface defects, surface defects states, interface, absorption, and desorptions. And in photoconductivity in zinc oxide nanowires, in a nanostructure case, the zinc oxide nanowires as compared to some other semiconductor nanowires, the lifetime of the unpaired electrons is further increased by oxygen molecules. Desorption from the surface when holes utilize the oxygen ions. Now you can see a schematic of trapping and photoconduction mechanism in the zinc oxide nanowires, how the charge carriers are moving up and down. Similarly, we have one of the important example based on zinc oxide, which is doped with the SN, tin. So the origin of a diverse photocurrent in such type of device, you can see here, rise and decay with doping concentration. So now this one is 2% shows the highest photoconductivity, but it has some negative photoconducting natures. And if you exponentially hit it, this a decay portion, we have done it exponentially. It is a single exponential decay fit. So the origin of diverse photocurrent in acid doped general sample that has been we have discussed here. So the negative photocurrent response under steady UV illumination that may be attributed to the 2 electron pulses. Carrier loss due to the trapping by the surface state and the recombination at the deep level states. So in contrast, the event of anomalous decrease in photoconductivity, you can see here, during illumination, now current decreases. Now you can see the schematic representation of this one, and this represent this schematic representation of charge port transfer person. In case of undoped one, it is case of 2% SN doped and 5% SN doped nanostructures, and the different events you can see 1 and 2 and 3 here. The event marked 1 and 2 that signify the carrier generation and oxygen desorption process respectively. Event 3 and 4 indicate the oxygen reabsorption on the surface states and capturing of electron in the samples. Now we have seen here in this table comparison of different zinc oxide conductor performances based on fabrication method, electrode used in the fabrication of devices, doping or treatings, and dark current value. You can see the responsibility. You can see here, and response and fall times.
So I request you, Dr. Mishra, to conclude.
Yeah. So I finally conclude lots of type of photo detectors are here, and we can do some good work. So this is my publication. Here. Thank you so much. Thank you to my team for giving me the opportunity to speak over here. Thank you so much.
Thank you, Dr. Mishra. And now the talk is open for question, but will be restricted only 1 or 2 questions only. So anyone? Anybody interested? Any query? Okay.
Yes.
If there is no query, I have one query from my side. Dr. Mishra, that we had been talking about these zinc oxide based photodetectors for 10 or 12 years, last 10 or 12 years. Now, what, according to you, what is your prospect of this material as a photodetector? Because nowadays we have got other materials also which are coming into picture. And how do you see the future? Whether we will get some photodetector, really some commercial photodetectors based on zinc oxide nanostructures?
Yeah, large number of workers or researchers are working on zinc oxide based. Even they are doing with the polymers, composites. So if you are doing with the zinc oxide, metal oxide with the polymer, zinc oxide with the polymer, you will find lots of good photodetectors, even flexible kind of photodetectors.
Okay. Okay. So if there is no other question, so let us thank the speaker and thank you, Dr. Mishra, and we'll move to our next speaker. So we have our next speaker, Dr. Abhimanyu Kumar Singh. Dr. Singh is working as an assistant. Yes, yeah. Yeah, Dr. Abhimanyu Singh is working as an assistant professor in the Department of Physics, Shyama Prasad Mukherjee Government College under University of Allahabad, Prayagraj. And he did his BSc and MSc from University of Allahabad and PhD also from the same institute. And he is also a nodal officer of colleges and different, serving as different members of the committees. And his major current research interest is in the fabrication of nanomaterials, drug delivery, etc. He has entitled 3 research books and published more than 30 research papers in peer-reviewed journals, and he's also a reviewer of many of the international journals. And so we are really lucky to have him with us in this occasion. So now I will request him to go for his presentation, and his title of the talk is Laser Ablation and Ultra Pure Synthesis of Colloidal Gold Nanoparticle and their Application in Biosensors and Drug Delivery. So over to Dr. Abhimanyu Kumar Singh.
Good afternoon to all of you. I am audible?
Yeah, of course. Yes, Dr. Singh, you are audible.
Yes.
Please share your presentation.
Just I am sharing.
Yeah.
Yes. Yes, my slide is visible.
Yeah, it's visible.
So, good afternoon to all of you. Firstly, I would like to thanks to organizer for giving me an opportunity to delivering a talk as an invited speaker in the conference on convergence of interdisciplinary science. So, my topic of talk, I am going to discuss the topic on an ultra pure synthesis of colloidal gold nanoparticle and their application in biosensor and drug delivery. I have divided talk in the following outline. First, I will discuss the laser ablation technique, basic principle of laser ablation techniques for fabrication of.
Dr. Singh, please go for the slideshow mode.
I have already set in the slideshow mode.
Okay, but we are still stuck in the first slide, I think. Anyone? Can you see the second slide? Changeover of the slides?
No. Maybe you have to again reshare. Then it will work, I think. Or screen share maybe. Google Meet. In Google Meet, the screen share will allow actually.
Okay. I am resharing.
Resharing but screen only, not PPT.
Okay.
Yeah.
Yes, my slide is visible.
Yes, now it's fine.
So, thank you for helping. So, I have divided my talk on the following outlines. First, I will discuss the basic principle of laser ablation technique, and then I will discuss the experimental setup of fabrication of colloidal gold nanoparticle, and then I will discuss the synthesis of colloidal gold nanoparticle for biosensor application and drug delivery application. So, since Dr. Misra has already discussed the very details in the nanoscience and nanotechnology, then I am not going to the details. I am just starting the fabrication of nanomaterial. There are generally two ways of fabrication of nanomaterial. First, bottom-up approach, which is generally called the chemical method, in which the material are synthesized by assembling of atoms, molecule, and cluster. And second is the top-down approach, which is generally known as physical method, in which the evolution of the property of a sample and its size is whittled down from macroscopic towards nanometric length. I have discussed here one of the top-down methods named as laser ablation technique, because it is very easy and rapid than the other techniques. This provide the green and eco-friendly approach for synthesis of metal nanoparticle, and there are large number of resizing and reshaping of colloidal gold nanoparticle process, and there are large number of available parameters for controlling the structure, shape, size, and morphology of the produced nanomaterial. This is the schematic diagram for production of the colloidal gold nanoparticle or any metal nanoparticle using laser ablation technique. So when high intensity laser beam is focused on a target material and explosive removal of matter from the surface of the target is observed. This phenomena is known as laser ablation. In the case of liquid ambience, such process leads to release nanocluster to the liquid environment. Finally, we get a colloidal nanoparticle. The process are usually in the form of nanoparticle that remain suspended within the liquid medium and can be isolated by filtration and evaporation of the liquid. So generally, the basic principle of laser ablation, this is the basic principle of laser ablation. So when laser beam is focused onto the target material, and first bond breaking and plasma shielding takes place during the laser pulse. After the laser pulse terminates, the plasma expansion and cooling process occurs. And when the third picture shows when the plasma cools below the boiling point of the sample of material, atom being condensed and form a nanoparticle. And if this process occurs in the liquid ambience, the colloidal solution will be available. So this is the colloidal nanoparticle, gold nanoparticle, and this is the photograph of colloidal silver nanoparticle. Here we see that the rich, beautiful colors is observed. This is a beautiful colors observed due to surface plasmon resonance. So surface plasmon resonance is basically when electromagnetic radiation interact with the metal nanoparticle, the oscillating electric field causes the conduction electron to oscillate coherently. The collective oscillation of the electron is called the surface plasmon resonance. For the metal nanoparticles such as silver, gold, and copper, the resonance condition is specified at visible wavelength. This is the origin of their intense color. So this is the bulk silver target, and this is the AU gold bulk target. And just put in the beaker and put 10 ml, 20 ml liquid, ultra pure liquid, or any biocompatible matrix, and focused the laser beam for 5 minutes, 10 minutes, and 15 minutes as concentration, how much concentration is required, then you will get a very fast formation of the bulk from the nanoparticles. So this is the photograph of the colloidal silver nanoparticle, and this is the colloidal gold nanoparticle. And this is the actual photograph in the laboratory for experimental setup for production of the colloidal gold nanoparticle using laser ablation technique. This is the Nd:YAG laser. And we have used the two harmonic, second harmonic 532 nanoparticle for the production of colloidal gold nanoparticle, and also the third harmonic 355 nanometer wavelength of laser for the production of gold nanoparticle. So this is the results. We have synthesized the gold nanoparticle in pure, ultra pure water, and also the chitosan caps gold nanoparticle. So we know that the chitosan is a natural biocompatible polymer, is well known for its hydrophilic, biocompatible, biodegradable, and non-toxic property. So this is the transmission electron microscopy, which is produced using the 532 nanometer wavelength of laser. And this figure, image B and C, is the gold nanoparticle, chitosan capped gold nanoparticle produced using 532 nanometer wavelength of laser, and this is produced 355 nanometer wavelength of laser. So we have calculated the average particle size about this is the 20 nanometer, and this is about same wavelength. This is the 15 nanometer, and here we see that the this is the gold nanoparticle produced in the only pure water. This is the, we can see that the black part is the gold nanoparticle, and from here we see that there is a core cell nanostructure is formed when the nanoparticle is produced in chitosan solution. And this is the selected area electron diffraction pattern, and this is the absorption band, absorption peak. So this red one is the production of the gold nanoparticle at 532 nanometer in water. This peaks is a surface plasmon resonance of gold nanoparticle. This confirms the formation of gold nanoparticle. And here we see that in green and blue, this peaks lower down due to the capping of chitosan onto the gold nanoparticle, and this peaks also form due to the formation of also chitosan nanoparticles. So we have also studied the fluorescence of pure gold nanoparticle and chitosan capped gold nanoparticle. So this we have get two excitation spectrum. One emission is fixed 386, and one emission is fixed 432. So we will get 342 nanometer excitation spectrum, and this is the 357 excitation spectrum. This is the emission spectrum which is excited by the 342 nanometer, and this is also a emission spectrum of excited by the 367 nanometer. This is the emission fluorescence spectrum of pure gold nanoparticle, and this is the emission spectrum of chitosan capped gold nanoparticle. We can see that we have get three emission peak when excited by 237, 253, 342. We will get almost 20 times enhance the emission spectra, and this can be used for biological motivated experiment, and also this formulation can be used for drug delivery application. So now I am going to the last part. So this part is the I have used the drug delivery for the diabetic management. So we know that the diabetic mellitus is a set of diseases characterized by defect in insulin utilization, either from autoimmune destruction of insulin producing cell or insulin resistance. Current treatment options include regular injection of insulin, which is very painful and inconvenient. So we have here used the oral administration of insulin using the gold nanoparticle. So this is the structure of the. I have used also one of the amino acid, which is the aspartic acid. So this is we can use chitosan or aspartic acid for capping the gold nanoparticle, and then we have loaded the insulin on this capped aspartic acid or chitosan capped gold nanoparticle. So this is this diagram shows that first this is the gold nanoparticle, which is firstly capped by aspartic acid. And then after capping the aspartic acid, we have loaded the insulin on the aspartic acid capped gold nanoparticle. So we have three different formulations. First, we have used the bare gold nanoparticle for diabetic management, and second formulation the capping of aspartic acid gold nanoparticle, and third formulation in insulin loaded aspartic acid capped gold nanoparticle. So this is the transmission electron microscopy, which is recorded by AIIMS New Delhi. So this is the transmission electron microscopy of bare gold nanoparticle, and this is the second B part is the transmission electron microscopy of aspartic acid aspartic acid capped gold nanoparticle, and this is the transmission electron microscopy of insulin loaded aspartic acid capped gold nanoparticle. So first we have tested the diabetic rat by the using total 9. We have tested this formulation onto the 9 rats, and we have taken the diabetic rat, which is greater or equal to 210 mg per dl blood glucose level. So this is the final result of different formulation delivered on the diabetic rat. So this pink this is the plot of time variation of blood glucose level in the diabetic rat after oral administration of different formulation of gold nanoparticle. We have taken dose 50 insulin unit per kg, and we have tested these experiment on the 9 rats. So the pink curve shows we have delivered first only bare gold nanoparticle on the diabetic rat, and the blood glucose level is tested to normal God pod kit in the medicinal laboratory of Allahabad University, and first so that on the delivering of bare gold nanoparticle on diabetic rat there is no changes the blood glucose level, and when the deliver insulin loaded gold nanoparticle, then there is only 23% reduction on the first hour, and then this is effect up to 2 hours. But when deliver the insulin loaded aspartic acid gold nanoparticle, there is almost 75% reduction on the blood glucose level on the first and second hour, and this is sustained up to 4 hours. So this formulation can be used to direct oral administration for the diabetic management. So I have acknowledged the IIT Roorkee, AIIMS IITR Lucknow Nanotechnology Application Center, Allahabad University Medicinal Research Laboratory, and Laser Spectroscopy Research Lab Group, Allahabad University. Thank you very much. If any question?
Thank you, Dr. Singh, for concluding in time. So now this talk is open for questions. Audience, please raise your hand for them. Any question from audience side? Yes.
Hi, Dr. Singh. I had a question for you. So, did you do any preclinical studies with these nanoparticles?
Yes, repeat, ma'am.
Did you get to do any preclinical, any study with the toxicity or with any other studies, preclinical studies with your nanoparticles in any animal models or?
Because I have used the ultra pure bulk material which is purchased from the Switzerland, which is purity is 99.999%. So there is no possibility for toxicity. I have also recorded the laser induced breakdown spectroscopy for the checking of impurity in the laser spectroscopy lab of Allahabad University, and confirms that there is no any toxicity in this formulation.
Okay, thanks, Dr. Singh.
Okay, welcome.
Okay, is there any other question? Okay, so I have one. You talked about the luminescence in gold or silver nanoparticles.
Yes,
both
yes.
remarks. What is in metal and because as far as that metal and the luminescence generally.
Sir,
until we have very fine clusters.
Your voice is interrupted. Please repeat.
Sayan, your voice is breaking.
Is it audible now? Am
Yes,
I audible now?
Now clear. Yes, now clear. Please tell your question.
Yeah. So, yeah, actually, my question is that in general, metal nanoparticles do not exhibit luminescence, any kind of luminescence, because we don't have that conduction band or valence band, etc., or some states we don't have. So, what is the origin in your results? What is the origin in photoluminescence?
So, because the luminescence due to interband transition between the field 5D10 band and 6SP1 conduction band. So in my case, I have used ultra pure water and also the ultra pure bulk substance. So, and this is the, and also the interband transition, the causage of fluorescence occurrence.
Okay. So if there is no question, so let us thank the speaker. It was a nice presentation on laser. So we have our next speaker, Dr. Jimli Sarkar. I think is there anyone to confirm whether Dr. Sarkar is present or not?
No, she is not present. Actually, due to fever issue, she absent.
Yeah.
Okay. So I think we should move to our Dr. Bandha. Let me introduce the speaker. Dr. Bandha is an associate director in Dr. Reddy's laboratory, and she received PhD in chemistry in Washington, and she did a postdoctoral for university at Yale University. And Dr. Bandha is with her co-expertise in
Sion,
Dr. Sayan, your voice is breaking.
your voice is breaking.
Dr. Sayan, your voice is breaking. Yeah.
You turn off your webcam.
Am I?
Yeah. Yeah.
Saurabh, open your camera also, yeah.
Am I audible?
Yeah, that's good.
Yeah.
Am I audible? Yeah.
Yes, you are audible.
Dr. Bandha is a director in Dr. India. She received her PhD in chemistry from University of, and she was a postdoctoral fellow for University and Yale. She is a multidisciplinary scientist with her core expertise in developing particulate-based platforms and different biopharmaceutical products. And apart from her career journey in these scientific activities, she made several prestigious awards, just like NRSA award from your Rudolph Anderson Fellowship from Yale University, etc. So now I would like to request Dr. Bandha, over to you.
Yeah, hi.
Dr. Bandha, it's over to you.
Yeah, hi. Am I audible?
Audible. Yes, you are.
Yes.
Yes,
Okay,
you are
because we
audible.
were not able to hear you properly. Yeah, okay. So can you see my screen?
Not yet.
Okay.
Not yet. Not yet.
Can you see it now? Can you see it now?
No, ma'am.
No, ma'am.
Then
You have to share your.
No.
Well, I did share. So can anybody from there and then share?
Yeah.
Because I have shared from.
I am trying to say. Okay, let me.
Okay.
Dr. Sayan, Dr. Saurabh, can I leave now?
Yeah, if you want, you can.
Thank you.
Is anybody able to share, or should I try again?
Yeah. No. I am just, ma'am.
Okay.
Yeah, thank you. Yeah, so thanks everyone for this opportunity. I am from the other end of the world, so it was very I couldn't attend all your talks. I just joined in, I think, the second last poster session. It was very early here in the morning. So good evening to you all. And so I was hearing at least the talks, and I am glad that my talk won't be so intense because I am coming, this is coming from the industry. So just a few quick notes. I couldn't hear what Shayan was actually saying. So I hope my voice is clear and audible.
Yeah.
Oh, okay, that's great. So yeah, so there's just a few changes. I have moved out of Dr. Reddy's for the last 4 months now. I was there for almost 10 years after finishing my PhD and postdoc here in the US. But after, so the last 4 months I'm not associated with Dr. Reddy's. Here I've moved to the US and joining a biologics manufacturing company here as a director in the here at Boston. So currently I have my things have changed, just I didn't add it in there. So since I have like my after my academic training, I moved to Hyderabad in India and had a very fascinating experience of making some very complex molecules, which we call complex generics. So I just have a story, a short story to tell you that what it is all about. You know, can we? So the okay.
Yeah.
Can I control the slide thing? Okay. Yeah. So when our drug innovator molecules go off patent, like usually when that is when there is a scope for us everywhere to make the like something copying the branded, which we call generics. It could be a big molecule, the biologics, or it could be the small molecules, which we call the generics. So whatever here I have is like, how do you evaluate this, right? Because when you discover a drug, we all know the effort that goes into it, like decades of work and that goes into, you know, screening and then coming to the right molecule and then all the clinical trials and everything, the hard work. So now here you have already something in the market and you are within a short period of time trying to copy it and say that you are equivalent to what exists in the market, and you are actually going to sell it at a much lower price. That is the advantage. You are making it available to the people, to larger pool of people here. So if you look at this pyramid here, naturally, since I will just focus on small molecules today. So what becomes most important for people like us, most of the Indian pharmaceutical companies, not the biopharma one, that chemistry of these molecules, that is where we actually spend most of our time. And then, you know, as you go up the pyramid, you see that there is something called pharmaceutical equivalence, bioequivalence, and lastly, the clinical study. So our aim would be to, you know, as much as possible, not to go for this large sort of clinical trials, because that's why you're coming in there with something that is already in the market, but then is it interchangeable with what you're making is your goal. So naturally, we put a lot of importance to mostly the in vitro and some in vivo studies to make sure that we are equivalent. And what we mean by those, I'll walk into my few next slides. Yeah. So when we are talking of the space that I will be discussing today, would, as I said, it won't involve any biologics or big molecules, but these are all complex molecules, which are the small, the smaller ones. Now, why are these complex? Right? Like these are not like simple solutions or tablets that I am going to discuss. So They could be complex because of a number of reasons, and that is what is enlisted here. So one thing is the API or the main, so the drug will have a main active pharmaceutical ingredient, right? The API, and it will have also a lot of excipients. So it could be that the API itself is a very complex molecule, complex in a number of different ways. Okay, so that could be one thing. The other could be the way you are delivering the drug, that the routes. It could be something that is topical. Okay, not systemic. So it could be ophthalmic, right, or topical. That makes, again, making such molecules, again, has their own, comes with its own set of challenges. Then the dosage forms or formulations, mostly we deal with two phases. So it's not like, as I said, not like one simple solution or one. It could be a suspension product or a liposomal product. So which you for the drug, for the delivery, right? And that it makes it, again, not only to make the synthesis of the whole thing, the characterization, but scale up there also becomes like a huge complex effort. And then last but not the least, would be packaging. Like, we sometimes also get drug device combinations, which could be very, very hard to make with the device part of it. So you again could have an auto injector or something along those lines, that a pre-filled syringe, or which again copying the innovator and being exactly same around, so that you are therapeutically equivalent, again makes it very challenging. And then there is a class, the opioid drugs, which are also, getting into that space is also challenging. Next slide. So I just want you guys to understand just one thing here is that when we make these molecules, two things become very important to us. One is the pharmaceutical equivalence, and the other is the bioequivalence. So as I said, we would like to avoid all the clinical trials and everything. So for us, it is basically having the same active and same inactive ingredients. Of course, you would also want to, control your impurities. That is one of the biggest challenges as well. And but sometimes, as I said, these are very complex because active ingredients, you can have more than one. So those mixtures also you'll have to be very careful about. So characterization here becomes like one very, very important for the generic players in the market. And then bioequivalence, like without establishing that you are actually making something which the rate of release is exactly the same as the innovator at the site of action, then FDA or any other regulatory body is not going to accept that as as similar or therapeutically equivalent to your innovator molecule. So not only the active ingredients, but the inactive ingredients also, you'll have to make sure that you do not have you're meeting all the clinical and safety profile there. Next slide. Yeah. So with the bioequivalence approach, what are the studies that usually we have? So for all these complex products, FDA usually comes up with a product-specific guideline, and these are very varied depending upon the class of products that we are dealing with. But in a general scale, we can say that this would be like, as we can think of, if you are supposed to establish the bioequivalency, it would be the PK and the PD, mostly like in vivo pharmacokinetics, pharmacodynamic study that we will have to match. But other than that, FDA can come up with any in vitro test or dissolution test, a dissolution rate test that they think would be suitable for measuring the bioavailability of our molecule versus the innovator molecule. So everywhere, what we have to do at each step is to keep the innovator molecules as a standard and then match all these different in vivo studies or in vitro studies with the innovator molecule and establish the equivalency. Next slide. So, so just to start with, like a very simple example. When we make these molecules, the first requirement for us is we need to be Q1, Q2 with the drug, with the branded drug. And what we mean by that is a branded drug may have 8 or 9 components, of which like 1 could be or 2 could be the active ingredients, and the rest of it is needed to make it as a drug. It could be a delivery vehicle, it could be different kinds of excipients, and it could have different functions for each of the categories that we mentioned. So one is you have to be exactly identical to the chemistry and the grade. So here is where the problem arises, because we have no idea of what grades the innovator had used. So for example, a polymer. A lot of these products have a lot of polymers, and polymers can come in like 1,000 different grades, right? So actually to characterize those grades and use the exact same one is sometimes becomes like a thesis in itself. But unless you are qualified for that, you will not be able to be Q1, and that's the very first criteria, that you have to be Q1. The second is you have to be Q2, meaning not only like all the different excipients and of course the API are the same, but the quantity wise they are also have to be exactly identical for the categories that I have just discussed, the different complex molecules that we are discussing here. So for that, FDA only allows like a plus minus like a 5% variability, which, believe me, when there are ingredients as low as like 0.1 mg in some of them, this becomes a big deal. So having a method which would go to the limits of detection of having you understand that within that very low quantity, you can detect between plus minus 5% and be there is a challenge in itself. So these, as simple as they may sound, but for some of these very complex molecules, this itself is a huge task, because in most cases, for some of these complex molecules, you may not know what is the quantity that is present in the RLD, or the reference drug that you're trying to copy. The reason being that's one of the trade secrets that the innovator has, and so you have to find it out using your own method, and then have something similar to that in your own molecule, and then correspond to the agency through different platforms, and go to them, giving yours and the innovators and saying that this is what you have come up with, and they will give you either a positive or a negative go ahead for this. Next slide. Yeah. So my time there was mostly spent on actually decoding, I would say, some of these very important parameters, which is Q1, Q2, and the next is Q3, which we'll discuss in the next slide. So these for mostly for parenteral products, injectable products, or ophthalmics and otic products. So in these cases, as I said, in most cases, FDA will accept, 99% cases, FDA accepts a bio waiver. And what we mean by that is that if you have a Q1, Q2, which I just discussed in the other slide, that you have the same ingredients as your innovator and in exact same quantity. And if then in vitro, if you do a lot of different studies that shows pharmaceutical and bioequivalence, then we do not need to do any clinical studies to establish therapeutic equivalence. And so these are the different examples that I have noted down here. It's as I said, all of these are extremely complex molecules to make in terms of their composition, their characterization, the process, and then of course scaling up. So each of these is actually a beast in itself. Like the suspension. First, I have an example of an injectable suspension. Then the emulsions, right? Then there could be liposomes, and then there could be ophthalmic suspensions. The ointments, gels, and in all of these, the lot of the excipients have like a very critical role in terms of their characterization and the composition and everything. So then examples of some emulsions, ophthalmic emulsions, cyclosporine, difluprednate, and then otic suspension, ciprofloxacin, dexamethasone. So all of these, many of them do not have a lot of generics out there, just because these are very extremely complex to be synthesized and to be made. Some of them have like a one or two. So the companies are highly focused to actually decode the innovators and come up with a quick copy of these complex products. Next one, please. Yeah, so this slide actually summarizes all that I was trying to probably make an attempt to say that what is it that we are looking at here. So if you look at the small molecule biologics, and mostly the classes that I was discussing here were the NBCDs, non-biological complex drugs. And of course, there are biological and other complex drugs also. So what this shows in the X versus Y axis is the degree of complexity involved in the pharmaceutical versus the bioequivalence of all these different kinds of drugs. Some of them, as you can see, which we call simple, so-called simple, are very low in the challenges that we face in the bioequivalence. Whereas, in terms of pharmaceutical equivalence, some of them are pretty high, but then there are some of these which, like the iron complexes, iron carbohydrate complexes, or the glatiramoids, these are actually extremely high in demonstrating both pharmaceutical and bioequivalence. Of course, for the complexity in the chemistry as well as the biology when it goes into the body. Next one, please. Yeah. So here I just give you this is an overview of what companies like these do. So some for example, one product here, a liposomal product here, which is again, as we know, liposomes are lipid bilayers, right? So they are encapsulating a drug here. In this case, it is doxorubicin, and then the surface has is pegylated. And so once you make this complex lipid bilayers, as I said, the characterization becomes key, and then you have like just a diagram to show that you have scanning electron microscopes and to show like how they look like, how the pores look like, how the lipid nanoparticles look like. And the next one, please. Yeah, so I spend a lot of time in my time there working with a lot of ophthalmic products. There could be emulsions, it could be suspensions, and we faced multiple challenges actually, because as I said, there are not a lot of generics out there in this space, and there are a lot of molecules that actually you can target and you can make. So first, again, in the challenges, first we need to figure out the Q1, and then we have the Q2, and then we go back. Sometimes we go back to FDA and propose our Q3. So what I mean by that is, in many instances, when FDA have this product specific guidelines as to how their criteria of establishing equivalence of these with the innovator, they would still ask for some clinical studies, may not be as in depth, but So what we do, the scientists, what we do is we take the innovator molecule, we characterize them fully. We understand the role, the composition, the nature of each of the excipients, and we write to FDA with our as a report that this is why we think if we characterize it in vitro using this following parameters, we should be able to say we are bioequivalent. Because again, for some of these molecules, these are not even systemic, right? So it is very difficult to do even a PKPD study, for example. So for that, you'll have to be completely in vitro with something called Q3, which is again the physicochemical characterization, the globule size, the particle size, the viscosity, the surface tension. So all these different properties which you establish with the innovator and your molecule, which we call the critical quality attributes of these products, and establish the similarity and go back to FDA and ask for a clearance. And we have been successful many of the times that if you have a proper scientific rationale saying why this would qualify for not doing a patient study, and if it is scientifically sound, then FDA will come back to you and give you the clearance that please go ahead and do these studies and show us the similarity. And we have been successful in multiple of such approaches. Next slide. So the other class of molecule that I have been involved with are the peptides. Again, these come with their own sets of challenges in a different way than the others that we were just discussing. So here again, these are peptides, so we'll have to be very careful that we're not into the biologic space here. It is just something which is less than 40 amino acids and fully synthetic usually. So here, what becomes again extremely key for us is characterization of just the API, which is called the drug substance. And then of course we have the different excipients and make it into a drug product. So then you go to establish the equivalence of pharmaceutical equivalence of the drug product. And the third thing, which becomes extremely key for such molecules, is the immunogenicity assessment. And this, with the last few years that I've spent in doctorate, I've seen that this is becoming extremely crucial for the agency as to how we take each of these steps for such high value products like some very important peptides, and you're trying to copy them, each of these steps, and establish equivalence. Next slide. Yeah, so these are some of the examples of some of these very complex peptides that I've been discussing about. Octreotide, just an 8 amino acid, but then it needs a delivery vehicle, so it cannot just be a solution. So usually it's encapsulated in a microsphere, the octreotide peptides. Then there are some simple molecules like the desmopressin, the bevaluridins, which are 9 amino acid, 20 amino acid, calcitonin also, where it can go into a solution, and it could be very simple to characterize. But then there are examples. I have just a few of them, of something like a teriparatide, which is a 34 amino acid long peptide, where the biological function becomes and the immunogenicity, the biological assays and the immunogenicity becomes extremely important for us to establish, because as we said, sometimes FDA will change their product specific guidelines based on if we do a proper characterization of all these equivalency and send so what happens is we get to and most of the time, 90% of the time, we get a clearance that we are fine. They would change their guidelines and get not include the other part, which is the clinical study. So in these cases, what we focus on basically is the functional, the structure function relationship for something like a teriparatide, like what is the different structural aspects of the molecule, and then how does that relate to the function. Various different kind of assays you have to do at various stages in use or during stability or after packaging, like, and you have to compare at all stages with the innovator molecule for this kind of peptides. Next slide.
Madam, we are all almost towards
Oh,
finishing
okay.
time. Yeah.
Okay. So I'll just I'll just conclude by saying that we spend a lot of time in the DMF, of meaning that the drug substance of such molecules, that we have to be very careful that what we make in house is because we don't copy the innovator process, we have no idea of the innovator process, right? So we make something which is clearly ours, and so that's what we file as the DMF. What we file as the next step for the drug product, the ANDA, that will include the formulation, where the structure, the function, and the biological activities and various animal studies, we do a host of animal studies, become very, very important. Next slide. Yeah, I'll just skip this slide. Just want to drive in the point that for such products, aggregates become a huge issue because of processing, and so that also biological activities of characterizing these aggregates also becomes very, very important for us. It's in the higher order structure. Next one. Yeah. So I'll just end by saying that in these molecules, impurities is what could be the game changer. So you have the RLD, and your generic has to be like very, very similar to the RLD in terms of the process and related impurities, as well as the impurities that come with the excipients and everything, which is almost sort of like an impossible thing to happen. So because as I said, they could be they're making probably via recombinant DNA. We are making synthetically, so they will never be the same. So so here is where a lot of challenges come in, and this is where a lot of scientific focus goes on how to solve these challenges, which are basically impurity related. Next one, please. Yeah. So so usually agencies, FDA, EMA, they will all come up with these numbers that, if you cross anything more than this 0.5%, you cannot say that you have made a copy of the molecule. You have to file it as a new molecule. And then what happens is we have to go through the NDA route, which is like a new molecule route. And that is actually a more time taking and a much more expensive process. So which is why these impurities become like very, very important not to cross that particular limit. Next one. So I think I have just a summary slide. And I think this is the most important slide that I wanted to discuss using the examples I've given below is the molecules that I discussed, the class, small molecules of extremely complex nature of different kinds of complexity. Like for a successful development, we need to understand why the reference product is complex. So for that, two things are very important. One is scientifically understanding the RLD, which is like you do basically a extremely thorough reverse engineering, so that when you go to the process, you can be as bang on as possible and not repeat it a number of times. Second is regulatory challenges. There are a lot of regulatory challenges that you'll have to face. So in the beginning, the scientific and the regulatory landscape should be very clear. You should have all the literature available for all guidances and petitions, and then make your own and approach to the FDA if you think you can come up with something better. And as I said, that has happened, has been accepted from our company multiple times for some of these complex molecules. And this is needless to say that, you have to be extremely critical of the science. I mean, unless somebody was doing it, you won't understand that it is maybe as intricate as discovering a drug in terms of the science. there is something called a pre-NDA program, which is a platform where you FDA has these days through the GDUFA program, where you can approach the FDA through different questionnaire, like anything that you think is not out there, but you think is scientifically relevant and is the way you want to do. So so a number of companies these days are using this program and trying to make it first time right by asking the right questions of how to decode and make these complex molecules. And then RLD, some of the molecules we work with were made in like 1950s, 60s, or whatever, and even today doesn't have a generic because of all the complexities involved, right? So you also have to be careful of like if there are changes that are happening in the RLD as we go 40 years, 50 years, 60 years down the line, and also how the regulatory landscape changes. So this is where I'll conclude and take any questions if you have.
Okay, thank you, madam. Thank you. It was really an illuminating talk. And now the talk is open for discussion. So anybody interested in any kind of query? Anyone? So if there is no question, so I have one simple question. Maybe it look very silly for you. Being a physics, I have very less knowledge in this kind of area. So my question is that do we require always complex molecules for drugs, any kind of drug system, or we can go with small molecules also?
Yeah, I mean, I wouldn't say this is a like whatever you're saying, naive question at all. I think it's a very good question. So I think because of the interest of time and because of my own interest, actually your answer is no, not at all. There are so at any point of time in a company as big as Dr. Reddy's, we run like 120, 140 products, right? And most of them are actually the simple molecules, right? So we being there is a scientific pool of people there. We handle this complex portfolio, and so our focus always been on this because scientifically these are very rich and very challenging. But yeah, most molecules are very simple. It's a matter of time that you copy them and send it out in the market. As I said, you have to have the same ingredients and the same amount, and then you make it, you package them and make sure that the stability, the packaging, everything, scale up, everything matches, and you are out there. Usually most of those are quite simple. There is the bus, but then the revenue you get out of it is not as high. But for these, as I said, something made in 1960s, 70s, and nobody ever since has been able to copy. For these, if you can crack one of these, I mean, you can understand the effect that it has. And in many cases, still the small scale, intermediate scale, we have been successful. But I think where we face hurdle is scaling up. I mean, that's a beast for such complex things. So I have just focused on a very small portion of the portfolio in terms of the number, but in terms of the value, this is what creates value in any organization, that you can be a step ahead because not a lot of people are actually going to end up making this kind of molecule. So your competition, you're ahead if you are able to crack this kind of molecule. So that's why I just focused on this part. And this is the only part I've worked with. So yeah.
Okay, that's true. Okay, so is there any question? So if there is no question, so let us thank the speaker. Madam, really it was a nice talk. So let's move to the next speaker. Yeah, thank you. So our next speaker is Dr. Madhumita Basu. So Dr. Basu is working as a chief scientist in Biosar and CNG Agro Private Limited. She did her PhD from Bidhan Chandra Krishi Vidyalaya, and she had done her BSc in agriculture, MSc in agriculture, and PhD biological control, and postdoctorate on molecular genetics. So we are have in this platform. So over to you. Madam, please turn on your speaker. Turn on your speaker.
Yeah.
You are muted. Yeah. Yes. Now it's audible.
May I audible? Hello.
Yeah.
Good evening. All
Yes,
the
madam. You
commentaries
are
over here.
audible. Yeah.
Okay. Okay. So I am Dr. Madhamita Basu. I have done my PhD from Bidhan Chandra Krishi Vishwavidyalaya and BSc AG and MSc AG from that university. And I have done my postdoctorate from Kalyan University on the molecular genetics. So I am very much fortunate that Science Dialectica give me an opportunity to present my topic over here. I am completely from another sector from you because I am completely from agriculture, and I have worked 20 years in organic farming and gathers all the experience and research data. So this is a generalized discussion by summarizing all the data. My topic is biofertilizer, a key player in sustainable agriculture. So we know very well that biofertilizers are biological preparations of efficient microorganisms that promote plant growth by improving nutrient acquisition. They enhance the soil productivity by fixing atmospheric nitrogen, solubilizing soil phosphorus, and stimulating the plant growth.
Sorry.
So, hello? Hello?
Madam,
Yes?
you have had your slide.
The slide is not shared.
Hello?
The slide is not
Ma'am,
shared.
Slides are not shared. Yes, madam, you are audible, but your slides are not shared.
Okay. আমি না এসবগুলো জানিও না।
Arpan, please guide her. Arpan, please guide her.
Yeah. There is a sharing option. Are you giving it from laptop?
Oh, this is my phone.
There should be a, I mean, at the bottom right hand side.
Yes.
There is that share screen. Right hand side to the hand.
Start now. Now you are sharing your screen.
Yes. Continue. Is there any slide? Open.
No. There is no slide.
Okay. That's the problem. So there is no slide. So it's better she continues.
Yes, madam. You can.
You have slide.
You can continue. You can continue as normal. You don't
Okay.
have to share anything. Yeah. Continue.
Okay. Now the biofertilizer, what I want to say that biofertilizer keep the soil environment rich in all kinds of micro and macronutrients via the nitrogen fixation, phosphate and potassium solubilization, or the mineralization release of plant growth regulatory substances. So production of antibiotics and the biodegradation of organic matter in the soil. So current soil management strategies are mainly dependent on inorganic chemical-based fertilizers, which caused a serious threat to human health and environment. The exploitation of beneficial microbes as a biofertilizer has become paramount importance in agriculture sector for their potential role in food safety and sustainable crop production. The eco-friendly approaches inspire a wide range of application of plant growth promoting rhizobacteria, endo and ectomycorrhizal fungi, and cyanobacteria, and many other useful microscopic organisms led to improve the nutrient uptake, plant growth, and plant tolerance to abiotic and biotic stress. We know very well that the conventional agriculture plays a significant role in meeting the food demands of a growing human population, which has led to an increasing dependence on chemical fertilizers and pesticides. So chemical fertilizers are industrially manipulated and substances composed of known quantities of nitrogen, phosphorus, and potassium and their exploitation. That causes air and groundwater pollution by eutrophication of water bodies. In this regard, recent efforts have been channelized more towards the production of nutrient-rich, high-quality food in sustainable compartment to ensure the biosafety. The innovative view of farm production attracts the growing demands of biological-based organic fertilizers, exclusive of alternative to agrochemicals. In agriculture, encourage, no, it is rather say in agriculture, encourage alternate means of soil fertilization relies on organic inputs to improve the nutrient supply and conserve the field management. Organic farming is one of the strategies that not only ensures the food safety but also adds to the biodiversity of soil. The additional advantages of biofertilizer include the longer shelf life, causing no adverse effect to ecosystem. Organic farming is mostly dependent on natural of the soil, which constitutes all kinds of useful bacteria and fungi, including the arbuscular mycorrhizal fungi called the plant growth promoting rhizobacteria or PGPR. Biofertilizers keep the soil environment rich in all kinds of macro and micro via the nitrogen fixation, phosphate and potassium solubilization, or the mineralization, release of plant growth regulatory substances, production of antibiotics, and biodegradation of organic matter in the soil. When biofertilizers are applied as seed or soil inoculants, they multiply the participate in nutrient cycling and benefit crop productivity. In general, we have to know that 60 to 90% of the total applied fertilizer is lost, and the remaining 10% to 40% is taken up the plants. So in this regard, microbial inoculants have paramount significance in integrated nutrient management system to sustain the agricultural productivity and healthy environment. The PGPR or co-inoculants of PGPR and arbuscular mycorrhizal fungi can advance the nutrient use efficiency of fertilizers. We know day by day the environmental stresses are becoming a major problem and productivity is declining at an unprecedented rate. Our dependence on chemical fertilizers and pesticides has encouraged the thriving of industries that are producing life-threatening chemicals and which are not only hazardous for human consumption, but also can disturb the ecological balance. So biofertilizers in this regard can help to solve the problem of feeding an increasing global population at a time when agriculture is facing various environmental stresses. So it is important to realize the useful aspects of biofertilizers and implement its application to modern agricultural practices. The new technology developed using the powerful tool of molecular biotechnology, nanotechnology, can enhance the biological pathways of production. If identified and transferred to the useful PGPers, these technologies can help provide relief from environmental stresses. However, the lack of awareness regarding improved protocols of biofertilizer applications to the field is one of the few reasons why many useful PGPers are still beyond the knowledge of ecologists and agriculturists. So it is a request to all the nanotechnologists, do something regarding the production of agricultural inputs and the spraying system and the application system as the crop productivity may increase. Nevertheless, the recent progress in technologies related to microbial science, plant pathogen interactions, and the genomics will help to optimize the required protocols. The success of the science related to biofertilizers depends on inventions of innovative strategies related to the functions of PGPers and their proper application to the field of agriculture. The major challenge in this area of research lies in the fact that along with the identification of various strains of PGPers and its properties, it is essential to dissect the actual mechanism of functioning of PGPers for their efficacy towards the exploitation in sustainable agriculture. Nanomaterials that improve the productivity of crops and efficiently regulate the delivery of nutrients to plants and targeted sites, guaranteeing the minimal use of agrochemicals. In conventional agriculture, an excess of fertilizer is applied directly into the soil or sprayed on the leaves, which suppress the nutritional need of the plant. This is because a very low percentage of fertilizer reaches its target site due to leaching of chemicals, evaporation, drift, hydrolysis, runoff, and phytolytic or microbial degradation. So this excess of chemical fertilizer relatively affects the nutrient equilibrium of the soil and causes contamination of local water supplies due to leaching of toxic materials into the water bodies. Nanomaterials can increase the crop yield by increasing fertilizer nutrient availability in soil and nutrient uptake by plant. This material can suppress crop diseases by acting directly on phytopathogens through a variety of mechanisms, including the production of reactive oxygen species. These materials also enhance the crop production indirectly by improving crop nutrition and boosting crop defense pathways. So, the efficient use of nanomaterials may reduce the negative environmental impact of conventional agricultural practices. In recent laboratory analysis, it has been reported that nanofertilizers can improve the crop productivity by enhancing the rate of seed germination also, seedling growth, and photosynthetic activity. Nanomaterials inside the plant root and leaf surface, which are the main nutrient gateways of plant systems and highly porous at the nanoscale. So the application of nanofertilizer can enhance the nutrient uptake by or of the plant through these pores, or the process can facilitate the complexation with molecular transporters or root exudates through the creation of new pores, or by the exploitation of endocytosis, or by ion channels. Additionally, several researchers have reported that a decrease in the size of nanomaterial facilitates an increase in the surface mass ratio of particle, and this enables the absorption of abundant nutrient ions that is later dissolved slowly and steadily for an extended period. Therefore, formulation of nanofertilizer can provide balanced nutrition for crop throughout the growth cycle, which in turn improves the agricultural production. Researchers and farmers need nanotechnology, such as nanoscale biosensors and nanoparticles, to get an inside look at and manipulate processes like the spread of pathogens. Innovations in nanotechnology can help safeguard food security and protect the public from pathogens in food, water, and environment. So friends, nanotechnology is one of the promising technologies that could improve the agricultural productivity via nanofertilizers, use of efficient herbicides and pesticides, soil features regulation, water management, waste management, and pathogen detection. So nanotechnology monitors a leading agricultural controlling process, especially by its miniature dimension. Additionally, many potential benefits such as the enhancement of food quality and safety, reduction of agricultural input, enrichment of absorbing nanoscale nutrients from the soil, etc., allow the application of nanotechnology to be resonant encumbrance. So the ambition of nanomaterials of agriculture is to reduce the amount of sprayed chemicals, minimize nutrient losses in fertilization, and increase the yield through pest and nutrient management. So nanotechnology has the prospect to improve the agriculture and food industry with novel nano tools for the controlling of rapid disease diagnostic, enhancing the capacity of plant to absorb the nutrients, among others. And the significant interest of using the nanotechnology in agriculture includes the specific application like nanofertilizers. So to conclude my topic, I must say sustainable agriculture must be taken as an ecosystem method where abiotic living beings live in accord with a coordinated stability of food chains and their related energy balances. To overcome the situation, it is mandatory to establish the recent technology in the food industry. Therefore, the new and future technology is nanotechnology that possesses very unique prosperity in food supply chain. Some focused areas may need more attention in near future researchers in the field of agriculture, nanotechnology, or nanofoods. So I am requested to all the scientists over here, think over that and apply your application through the nanotechnology. Thank you very much.
Thank you, Dr. Basu, for this nice talk on this biofertilizers, their scope, prospects, etc. So with this, we had an excellent session where we heard talk about different sectors, right from the technology to medicine and to agriculture. So in the first talk, Dr. Shiv Kumar Mishra gave us some details about the basics of nanotechnology and the fabrication of photodetectors and their different parameters, just like your cap depth, wavelength dependent efficiency, etc. Next, we heard Dr. Abhimanyu Singh. He gave us an idea how laser can be used for fabricating colloidal metal nanoparticles and how they can be used in drug delivery cases. Next, Dr. Arunima Bandyopadhyay had given an illuminating talk on complex molecules for different drug systems, and she gave us an idea about the complex peptides and other other complex molecules which are useful for this kind of drug systems. And finally, Dr. Madhumita Basu presented a beautiful talk on biofertilizers, how to increase the efficiency of fertilizers, how we can have environmental issues with the conventional fertilizers, and how biofertilizers can be used to achieve to solve these environmental issues, and how one can increase the nutrition factors in plants using these biofertilizers. And she also emphasized to the nanotechnologist to go for some route which can be useful for developing the biofertilizers. So with this, I want to conclude this session, and now I want to hand over it to our convener, Dr. Arunima Bandyopadhyay, for the concluding remark.
Yeah, thanks. Thanks a lot for that. So I think we have the names of the three winners for the poster session announced. Of course, everybody has done an excellent job, and it was a great, a great enriching session. You guys must be very tired from 11 in the morning to probably 6:30 there. So just a concluding note. So we have the names of three of the best poster presenters. The first place is Shushmita Mukherjee. The second is Raka Das. And the third is Sunil Luhar. So with that, we will just conclude, and thanks to the excellent effort. I'm sure for these 2 days, a lot of effort has gone from all the Science Dialectica editors and the board and everybody. Thank you all for such a great session, and I hope we continue the trend, and we all remain connected. Thank you. Thanks a lot.
Yeah, I'm back. I don't know how much is the program ended.
Yes.
Program concluded. I just joined right now, so that announcement is done.
Yes, yes, yes.
Okay. Okay. So shall I take one photo? Oh, who is the first? That Susmita. Are you around?
Sushmita Mukherjee first.
Susmita.
Second, Yanka Das.
Yes.
Yes, sir.
And
Can you-
third, Sunil Luhar.
Sunil Luhar is around. Sunil Luhar is around. Okay. Those two are present. You just turn on your webcam so I can take your photograph of both of you.
Minutes. I'm trying.
Am I audible, sir?
Yes, yes, yes.
Yeah, yeah.
Congratulations. Yeah, it was really difficult job for judges to judge all of these around 40 posters. So it was really, so I know that the results are very close, but I must congratulate to all of three of you. So it's really very nice. So can you turn both of three?
May I ask, sir? Actually, I didn't. Hello, am I audible, sir?
Yeah. Yeah.
Hello. This is Sunil, sir.
Yeah. Okay. So can you turn on all of you? I want to take a snapshot just. Okay.
Sir, just a minute.
Yeah. Because it's too late. Yeah. So all of the presenters, you please send your details. Those who own the bank details, you just please send me. Okay, through that conference email ID. And the other things, all of you will get the conference certificate. But don't mail us. We'll timely will send you all the certificates and everything. Okay. So give us time something. Okay. Okay. Yeah. So turn on camera, please. Yeah. One more.
Am I visible, sir?
I need to see. No, you are not visible. I think
My phone.
securing first position, you become invisible.
So may I ask again which position I got? I didn't actually. I was a problem.
He is in third position, right? Subramsura?
Yeah, Sunil is.
Yeah,
Okay.
Sunil is third. Susmita is first, and second one is Riyanka.
Okay.
Yeah.
Sunil Luhar third position.
Yeah. Yeah, I am. And I wanted to take only 3 winners of that. Just only 3. Others can turn off your only 3. Yeah. I also want to switch off my.
Sushmita.
Sir, can Dr. Abhimanyu, sir, can you turn off the camera? Just I wanted to take off these 3 people. Yeah. Only 2. The Dianka is. She knows her result. Yeah. Thank you.
Welcome.
I hope you really enjoyed this the 2 days conference. Okay. So there is a special announcement for all of you. We are going to start a scholarship but not for science students. It's for engineering students. So we will implement this scholarship from this academic year. So this is 4-year scholarship program, and those who are first year BTech student, but obviously there is some rules and regulations there. You can go to our website srfglobal.org. So that from there you can go get the details of that of the scholarship. So basically those who are from economic problem, economic challenged family, so we'll offer the scholarship for there. There is one for girl, one for boys. So 2 scholarship we will support. Okay, for 4 years. Thank you. Thank you. Thank you. Thank you. Yeah. Thank you. Thank
I
you.
guess on behalf of the participants, I would like to thank Shubhranshu and Saurav for this wonderful job that they have done, and also of course there are a lot of others also who have participated and worked, and it's really nice. And I guess
Without you all, we cannot do anything.
well, of course, our job is the easiest part, I guess.
Everybody has quantum. See, they are presenting. They are also contributed to us. You also, judges, you have presented. You also some contribution. So this is
true, but I think the entire thing has to be held together by people, and has to be the idea of doing this and all that. So there are a lot of people who are behind that, and I would like to thank all of them, and I think that's it deserves a round of applause. But unfortunately, right now we are just on camera.
One more announcement I wanted to. So maybe from next year onwards, we'll have a hybrid mode conference. So both you can go to that offline and online. So that will be actually we are planning to do. So hopefully the next year will be another exciting event.
Sure,
okay.
Sure. Looking forward to it. Okay.
Okay. Thank you. Bye bye. Bye. See you all. Thank you.